All right, students, good afternoon, morning in Jamaica, afternoon in Trinidad. So we're gonna focus on module 2 today, right? So it's
All right, students, good
hold on a second.
afternoon.
Right, so it's trigonometry, vectors, coordinate geometry. Those are the topics for module 2. And under the trigonometry topic, we also have circular measures. Circular measures. All right. We want to cover module 2 today, but I sent a message earlier that we did not finish module 1 yesterday. We still have logs, surds and indices and inequalities and linear reduction to do. And what I'm proposing is that after the session today, we take a 3-hour break, and then we can come back and try to cover those topics tonight. It will start at 8 p.m. in Trinidad and Tobago, and maybe work 2 to 3 hours. And it will start 7 p.m. in Jamaica, same 2 to 3 hours. So that's what I'm proposing for today. And that way we will clear module 1 and module 2, so that we can go on to module 3 tomorrow, which then will be the differentiation and the integration and some kinematics. And then we'll have Monday to do the statistics and the probability. But if we can get to it tomorrow, the statistics and the probability, then fine, we get to it. But then we want to have a session at the end where we can have a freelance sort of session where persons can ask questions and just ask for some stuff to be explained some more. All right, prior to the exam. If time permits, it would also be good for us to do a multiple choice paper or 2, because the multiple choice helps the paper 2. The paper 1 helps the paper 2. So even though the paper 1 exam is later down in June, it still will be good if time permits for us to do 1 or 2 multiple choice papers, because those will assist with the preparation for the paper 2. All right, so let's go. So we're going to start with trigonometry. We're going to do the same as we did last night. So we're going to basically do all the trigonometry questions from the specimen paper all the way down to 2012. And it's not a teaching session, it's a revision session. So we are doing the questions in the assumption that you would already know the topics or the basics of the topics, and we'll just explain as much as possible without actually teaching the topics from scratch. All right, so that is the objective, that is the aim. All right, so let's go. So this is a specimen paper, and this is the only trigonometry question on it. All right, this is actually number 3. So basically, we're coming back to this question. We'll do the circles, equation of a circle, coordinate geometry. Here is vectors, and here now is our trigonometry on this paper. All right, so let's go. So this question says, they are giving us tan of pi by 4 is 1 and pi by 4 is 45 degrees. These are some things angles that we should know. The tan of that's pi by 6 is 30 degrees. Tan of 30 degrees is √3/3. It says, without use of a calculator, we are to evaluate this tan of pi by 6, tan of pi by 12, sorry, tan of pi by 12. So what it is that we want to break down this pi by 12 and want to establish these angles that they gave us, and it does not have to be these angles, right? So if they gave us these angles, I'm telling you now, you don't have to use those angles, right? Because sometimes they will give you angles and it is a pain to find those angles. All right, so what I'm going to do, I'm going to take the tan of pi by 12. I'm going to recognize the pi by 12 as the tan of 4 pi by 12 minus 3 pi by 12. And I know this because this pi by 12 is one of those regular angles that they give us. The 4 pi by 12 right here is the same as pi by 3. So this is become the tan of pi by 3 And this 3 pi by 12 becomes pi by 4. And so we are basically using this. And so we have to use a compound angle for tan. And let me write the compound angle for tan over here. It's on the formula sheet. Right? The compound angle is on the formula sheet. So if you don't know it, it's on the formula sheet. It is right here. Note carefully, when you have a plus, then you have a plus here and a minus there. And when you have a minus, you have a minus here and a plus here. So right now it's a minus that we have. So the one that we are using, right? And we can here. Right. The one that so it's good to know, right? It is times B is equal to minus the tan of B divided by 1 plus the tan of A times the tan of B. If we just know use them, right? This is what we're gonna use. All right, we're gonna be using this. A is our pi by 3 and the B is our pi by 4. So this becomes equal to the tan of pi by 3 minus the tan of pi by 4 divided by 1 plus the tan of pi by 3 times the tan of pi by 4. Right? Now they gave us the tan of pi by 4 here, which is 1. What they did not give us was the tan of pi by 3. Right? That's why it's good to know. Now the pi by 3 is actually 60 degrees, and the tan of pi by 3 is root 3. So I can write it right here. They did not give it to us, but it's good to know that I can write it here. The tan of pi by 3 is actually root 3, because pi by 3 is 60 degrees, tan of 60 degrees is root 3. But you should have a calculator that you can work this out if necessary in the search form. All right? So I'm going to just place those values here now. So this then becomes equal to the tan of pi divided by 1 plus the tan of pi by 3 is root 3 again. And this is equal to 1. So this remains root 3. Basically, that's the answer right there. It's in its simplest form. Evaluate this in simple search form. So that is it. So the only thing I might want to do with this is rationalize the denominator. But I feel like if you leave this as your answer, then you go, because this question is not testing your ability to rationalize the denominator. It's testing your knowledge of this. This is what is really testing. That you can break this out and that you know that you can use a compound angle there. All right, so I'm going to leave it right here. But I go do that?
Yes, sir.
Okay. All right, good. All right, so that is the specimen paper. So I'm going to jump to the 22 paper now. I'm looking for the tricks question on the 2022 paper. All right, I don't think there's another tricks on this. I'm just check. Right, going to another question. I'm going to look for the 2022 paper now, which is right here. And the tricks is usually number 3 or number 4. So this is a tricks question. My part A is vectors. Right, so it's number 3 again. And the trigonometry starts right here. Right. The question says we have to show that this equals this. Now, this is actually an identity that I would want my students to actually know. Right? That's a compound angle, the double angle for cos. Right? But because I have to prove it, I have to use this side, use a compound angle formula to prove this. So that's what we're gonna do. We start by saying the left-hand side is a proof. Start with the left-hand side. This meaning I'm talking about this side is equal to. Now this 2 theta, I'm going to write it as the cos of theta plus theta. And I'm using a compound plus up here plus b is cos minus sin. Cos minus sin. What do I is equal to? Cos means it's cos A plus B minus sin A. A sign you have in between here, you put the opposite sign there. If this was a minus, then you would put a plus right here. All right? So in any case, it is cos sin. Cos sin. So if I use this, what happens here is that the A and the B is equal to theta. That's what is happening here. Theta is equal to the A and the B. So then this will become equal to cos theta becomes cos squared theta. So this will become cos squared theta. That's this first part. Minus sin theta. And so it will become sin squared theta. That's what I will get initially. But this result is in terms of cos squared alone. So I need to get this sin squared removed. I'm going to draw for the identity that says sin squared theta plus cos squared theta equals 1. You must know that. They're not going to put this on the formula sheet. You must know that one. And so if we make sin squared theta the subject, then sin squared theta will be 1 minus cos squared theta. And it will be good if first just know this one straight off the bat and write it down. Right? You don't need to write the first one. You don't need to write this one first. You could just write this one down. Right? Put the equal sign there and just write this one down. So we are replacing this with 1 minus cos squared. Right? And so when we do that, it will become cos squared theta minus bracket 1 minus cos squared theta. When we expand this negative over here, this minus cos squared is going to become a plus cos squared. And so we're going to add to this one and give me 2 of them. Because I'm going to get the 2 cos squared theta. And then this minus 1 and this minus and that one is going to give me the negative 1, which then is the right-hand side of the proof. And that we can say was shown and proven. What are we going to do with that?
Yes, sir.
All right, good. That was the proof. It says now, hence. Now, hence means that we have to use the result from up here. Hence, use that result to solve this equation. So what it is, if we zoom in on this, what it is that we want to replace this cos 2 theta, because this is cos. We cannot change the cos. But this cos squared is a very powerful double angle. It can be written in terms of sin squared. I can write in terms of cos squared. This time I want to write it in terms of cos squared because this is a cos. And the cos squared that this is what we just prove. We just prove that it is the same as 2 cos squared minus 1. So we're going to replace this cos 2 theta and the equation is going to become 2 cos squared theta minus 1. That's what this became based on the proof. And then we're adding back the cos theta and the plus 1 equals 0. I'm solving between 0 and 2 pi. And we're working in radians. So basically, I have this equation to solve now. This is actually a quadratic equation. Now, this negative 1 cancels with that positive 1. And so it reduces to 2 cos squared theta plus cos theta equals 0. So that's a quadratic equation, but there are only 2 terms, and so there's a common factor of cos theta to factorize. So it becomes cos theta into 2 cos theta plus 1 equals 0. So from this side, I'm going to get cos theta equals 0. And from here, I'm going to get cos theta equals minus half. So how do we solve these now? How do we solve these and put them in the correct quadrant? Because we're going from 0 to 2 pi. I'm going to draw the quadrant diagram for this one. Let me make this a little smaller. So we have more space to work with. You can zoom up on it. Right, so I'm going to draw the quadrant diagram for this one. Now, what you do when it is 0, treat the 0 as if it's positive. So remember, we want the quadrant, our answer is going to be in the quadrant where cos is positive. All right. Now remember, the system is ASTC. I call it cast, spell around here. Whichever way you want to remember the quadrants, that is it. But all three ratios are positive in this first quadrant. Sine alone is positive in the second quadrant. Tan alone is positive in the third quadrant. Cos alone is positive in the fourth quadrant. I want where cos is positive. I'm treating the 0 as a positive. So the two quadrants I want are this one and that one. I'm marking the quadrant that I want. Then you want to find the principal acute angle that would be inside here, because there is an equivalent angle in each quadrant to that principal acute angle. The principal acute angle is usually represented with the symbol alpha, and we do cos to the -1 of the 0. And that alpha is actually pi by 2. It's good to know that the cos of pi by 2 is 0. Pi by 2 is 90 degrees. The more things you know, the easier the question is to do, because you won't have to do this in a calculator. You should know that this is just pi by 2. And so our theta angle that we want now, over here, would be the equivalent of pi by 2 in this quadrant, which is pi by 2 itself. And then in this quadrant, the fourth quadrant, is 2 pi minus alpha. This quadrant is 2 pi minus the alpha. And so the angle there, that quadrant, would be 2 pi minus pi by 2. So to write the values, then the theta will be pi by 2, and this now will be 3 pi by 2. This will work out to 3 pi by 2, because this 2 pi is the same as 4 over 2. 4 minus 1 is 3, so it's 3 pi by 2. All right? Then we want to work out this side now. We need to solve this one now. So I have to draw the quadrant diagram for this as well. So the quadrant diagram for this now, the same process, draw the quadrant diagram for here. And I want where the cos of an angle is negative. Our quadrants that we want is where cos is negative. Now cos is positive here and here. And so the two quadrants that we want is here and there. So we want those two quadrants. But we need to find the principal acute angle first. And so it's the alpha is equal to cos to the -1. And be very careful right here now, guys. The alpha is always cos to the -1 of the positive value. The negative value, the negative on the value, is taken care of by us selecting these two quadrants. So to get the principal acute angle, we use a positive, cos to the -1 of the positive value. So it's a half. But it's cos of 60 degrees that's equal to a half. 60 degrees is pi by 3. Again, it's good to know these things. And so the alpha, if you use a calculator, will be pi by 3 in radians, which is 60 degrees. And so we want the equivalent of pi by 3 in this quadrant and also in this quadrant. Now, in this quadrant, the equivalent angle is pi minus alpha. In this quadrant, it is pi plus alpha. Those are the equivalent angles. So that's where our theta angles are going to be. So our theta angles in those two quadrants, let's write them down here, is going to be pi minus the pi by 3, because this is pi by 3 is alpha. And in this quadrant, it's going to be pi plus pi by 3. And if I were to write the values, this is the same as 3 over 3. So it becomes 2 pi by 3. 2 pi by 3. And this is again the same as 3 over 3. So it becomes 4 pi by 3. 4 pi by 3. And so these are your 4 values, your 4 angles. But you need to put them in ascending order. So I'm going to write and I'll answer over here in ascending order, my answer. And I want to put them in ascending order. But the quadrants that I ticked will help me to know them in ascending order. Right? So this is the first quadrant that I ticked, corresponding to this angle. So the first value I'm going to put is that theta is equal to pi by 2 for the first quadrant. This was the second quadrant that I ticked over here, corresponding to this value. So the second value in the ascending order is 2 pi by 3. So that's 2 pi by 3. Third quadrant that I ticked is this one, corresponding to this value. That's 4 pi by 3. That angle is in the third quadrant, which is 4 pi by 3. And the last quadrant that I ticked was this one over here, corresponding to this value. 3 pi by 2. So the last angle is 3 pi by 2. And these are my answers. But I go to that?
Yes.
Body okay. All right. So I think that finishes that tricks question. I like this one a lot. Now let me show you something. Just for additional work. Let me just show you something. More maths equals better, right? Something can pass. It could have been that for this same question right here, instead of a cos theta, that could have been a sin theta with the same cos 2 theta here. Or how would we approach it? Let me do it over here. More maths equals better maths. It could have been cos 2 theta plus sin theta plus 1 equals 0. Could have been that, you know. Now, cos 2 theta is the most powerful double angle because it can be written in 3 ways. Let me show you the 3 ways it can be written in. Cos 2 theta can be written as cos squared theta minus sin squared theta, or it can be written as we did over here a while ago as 2 cos squared theta minus 1, or it can be written as 1 minus 2 sin squared theta. I will get to these by substituting for this one and replacing it with 1 minus sin squared theta. That's how we end up getting this. Or we could substitute for this one and write it as 1 minus cos squared theta, and that's how we end up with this one. All right? So we have to know the trig identities like that. Now, because this equation has a sign in it, it kind of makes sense for us to replace this cos 2 theta now with this and generate a quadratic in sine. Generate a quadratic in sine. Right? So I'm not going to say it's going to work, be possible, but let me show you what would happen. So this equation would then become, because I'm replacing this now with this one. And so it will become 1 minus 2 sine squared theta. And then I'm adding back these. Plus sine theta plus 1 equals 0. If you write it as a quadratic, and I want my square term to be positive, let's consolidate it first. It will be minus 2 sine squared theta plus sine theta plus 2. Because 1 and 1 is 2 equals 0. Then I want my square term to be negative, and so I'd multiply 2 by a negative 1 and get 2 sine squared theta minus sine theta minus 2 equals 0. And maybe this can't work because it can't factorize. Or you have to use a quadratic formula to solve it. Right? You have to use a quadratic formula to solve it. Right? Because this cannot be factorized. Cannot be factorized. So maybe you have to use a quadratic formula and write that sine theta will be equal to minus b. The b is 1 right here. So it'll be minus a negative 1, which gives me a positive 1 using the quadratic formula, plus or minus the square root of b squared. The b is 1 again, so it'll be 1 squared minus 4 times a, the a is 2, times c, the c is negative 1, negative 2, all everything divided by 2 times a, the a is 2. A is 2. So we'd have to solve this with the quadratic formula. And so sine theta will basically be 1 plus or minus. This will become a positive 16, and 1 makes 17. So it becomes the square root of 17 divided by 4. And you have to work out the value for the plus and then work out the value for the minus. If you follow through with it, then sine theta will be equal to what? Can somebody work out the value with the plus for me, please? With the plus and divided by the 4. Yeah? That it as here. And then you want to work it out with the minus right here. Work it out with the minus as well. So tell me the two values. One with the plus and one with the minus. And let's see what's that. The one with the plus is not going to be valid. Right? Because sine cannot be outside of 1. But let's see. I will divide them by 4. Let's see what it is. So work out the one with the plus and work out the one with the minus. Huh? No, just tell me in decimal. 1.28. Just give me 3 digits. 1.28. And what the minus is what?
Negative 0 point.
Negative. Let me shift this over. Let me shift this over a bit. Yeah, negative 0 point what?
781.
781. Now what will that mean now? This one would not be valid. This one would not be valid. Anybody can tell me why it's not valid? Why is that one not valid? Nobody can tell me why that one is not valid. It's not valid because sine and cos, sine of an angle, has to be less than or equal to 1 or greater than or equal to negative 1. Cannot be outside of 1. Cannot be 1.2. Right? And we can know this because remember that if you have a right angle triangle with theta, you have the opposite over the hypotenuse. The hypotenuse is longer than the opposite. The hypotenuse is longer than the opposite. So if you put in the opposite over the hypotenuse, then it must be a fraction. The most the opposite can be is equal to the hypotenuse, but it cannot be longer than the hypotenuse. All right? So this thing has to be a fraction. So sine of an angle has to be a fractional value or 1. It cannot be more than 1. So that is why this has no solution. And so we would only be able to solve this side. And so the quadrant diagram for this one, if we just finish it, while we're on it, if we were to finish this one, let me write it down under here. So we're solving now sine theta equal negative 0.781. And so we'll draw the quadrant diagram for this. We want where sine is negative. Now sine is positive here and here. We want where it is negative. So the two quadrants that we want to be this one and this one. Then again, you have to find the principal acute angle alpha, which is sine to the minus 1 of the positive value here. Very important to remember. It's of the positive value. You're trying to find the acute angle that will go here if you wanted it, just that we don't want it. But that positive angle, that acute angle alpha, can be used to find the angle inside here and also the angle inside there, because there are equivalent total angles to that acute angle. So this is 0.781. Put the calculator in radians and work it out for me and tell me what to get in radians. Alpha equals what? What is that? 0.896 radians. But remember now, our theta is in this quadrant and also in this quadrant. This quadrant is pi plus alpha. This quadrant is 2 pi minus alpha. You have to remember those things. And so our total angle that we want, our theta angle, right here, will be equal to this quadrant, which is pi plus the alpha, which is 0.896. Or this one will be 2 pi minus the 0.896. And then you can use a calculator and work out each of them and give it to me in radians. Let's use the pi in the calculator. 3.14. Use the pi value in the calculator. Work this out. What is it? I'm going to write it to 3 significant figures, or 3 decimal places. Talk to me. What is that one?
4.03. 04.
4.04?
Yeah.
4.04 radians. And this one will be what?
5.39.
5.29 radians. So that is what you would have to do, guys, if this thing right here was a sine. Where is it? If this was a sine. 5.39, not really much. 5.39. Cos as they give us here, we had a sine over here. All right. Cos double angle is the most powerful one of the three because it can be expressed in three ways. All right. Cos double angle can be expressed in three different ways. So depending on what you want to do, you use this one or this one or this one. These two are used maybe 90% of the time. This one is hardly used. Hardly used. All right. So these are the two that are used equally half the time or more than half the time. All right. So it's good to know these things. All right. That finishes the paper on 2021. All right. 2022. Sorry. We're going to jump to 2021 now. 2021. Don't think there's any more tricks on this one. 2021. So let's go to 2021 now. 2021. So where is 2021? It's right here. I'm looking for the tricks. All right. This is the tricks on 2021. So this question says cos theta is 24 over 25 and the angle is acute. Now, once the angle is acute, you know that you're working in the first quadrant, and it means that the sine of M is positive and the tan of M is also positive, all right? Because the angle is acute. If they had said obtuse, then you'll be working in this quadrant where tan is negative and cos is negative and sine is positive. And because this is a cos angle, it could have been that we were working in the fourth quadrant down here, where sine is negative and tan is negative as well. All right. So most times they give you acute or obtuse. But let's go. So it's acute, so everything positive. They want us to determine this tan of 2m. Now they don't want to define m first, you know, guys. They don't want that. Right? How many marks for the question? 4 marks. They don't want you to find a method where you go m equal cos to the minus 1 of 24 of 24 over 25, work out the angle, and then do the tan of 2 times that angle. A lot of persons will do that. You're not going to get in marks if you do that. They want you to use your trigonometry identities. And what they will sometimes say is to do it without the use of a calculator. All right? Do it without the use of a calculator. All right. And sometimes what they say also is that for you to give the exact value. All right. So we're going to do this. So what we're going to use is a compound angle for tan, the double angle for tan. But first, we want to use this to see what the tan theta or the tan m would be. And since they gave us one trig ratio, an easy way to find the other trig ratio is to draw the right angle triangle related to that trig ratio. Let's make a sketch of it. Put the m angle right here. And we know that cos equals adjacent over hypotenuse. So the adjacent will be 24, the hypotenuse will be 25, and then we use Pythagoras' theorem to work out that side. Using Pythagoras' theorem to work out that side, then the x would be equal to the square root of 25 squared minus 24 squared. All right? Cos is adjacent over hypotenuse. And so that will become what? 25 squared minus 24 squared. Somebody work that out for me. I think that's a 7. It is a 7 because this is different. Yeah. Right, it's a 7. You could also know the Pythagorean triple 7, 25, 24. The Pythagorean triple 7, 25, 24. So it means therefore that the tan of m is equal to opposite over adjacent, which is 7 over 24. And I don't need the sign of m. Oh, I know that I don't need the sign of m. Because I know that the tan of 2m can be expressed in terms of tan m alone. So I don't need sin m. All right? So I'm going to work out the tan of m. Let's go for a different color. All right? So I'm going to say now, the tan of 2m is 2 tan m, 2 tan m over 1 minus tan squared m. This is not going to be on a formula sheet, you know. No, I know this in my head. More you know, the easier the questions will be. But how could you get this from the formula sheet if you don't know it? Because what they give on the formula sheet is the identity for A plus B. Tan of A plus B, if you look at the formula sheet up here, I think it's here, right? They give you this one. They give you this one right here. That's all they give you. So if you don't know 2m, you have to treat this as the plus firstly, with the plus and the minus. And you have to treat this as m and m. That's why you get the 2m. So it's m plus m. So this will be the tan of m plus the tan of m, which is how we get the 2 tan of m, divided by 1. Then it's the minus. I've circled the plus, but it really should be the minus. Tan of m times tan of m is tan m squared, or tan of tan squared m. That's how you will get it, by letting the a equal m and the b equal m, and you're using the plus. Right? But it's better to just know this formula, just know the identity. Right? Just learn the double angle identity. It's just easier when you know stuff and you don't have to go figuring out stuff in the exam room. It makes sense to know things that you know they will set questions. Right? Stuff that you can know, rather than to go figure it out. Next thing you figure it out, I still make a mistake and put a plus here, for example, and get it wrong. All right, so I'm just going to substitute the values now. So this becomes equal to 2 times the tan of m, which is 7 over 24. Let's write that better. Divided by 1 minus 7 over 24 squared. That's tan squared m. And let's drop this in the calculator now and tell me what you get. And that is the answer. Put that in the calculator for me, please. What is it? Anybody? I have to do it myself.
Probably so.
336 over what? Over 527. So that's what we're getting in the calculator. So that's the answer. All right. But go to that. That finishes that question. So you see, the trigonometry is really a little bit, it's kind of some 4 marks question. And it's very easy because I don't consider this trigonometry. That's vectors, right? And that's equation of circle. What in geometry, right? That's 2021. Let's go to 2020, well, 2019, but there was no exam in 2020, as you know. No paper 2. It was 2019 next. 2019, where are you? 19 is the one here, 19. All right, so going for the trigonometry on this paper now. Searching for the trigs. That's vector. So there's more trigs on this. I don't see any trigs. That's the next question. Question 4. This is a trigs in that circle. We're going to do this later. All right, this is a trigs. Right, that's a trigs. It says a right angle with the sine of 5 over 5. Again, this is basically a similar question. You evaluate it this time without evaluating. They don't want you to do. Can you still screen, students? And can you hear me still?
Yes, sir. Yes, they can
Hello?
all.
All right. This thing just kind of unstable, so just bear with me. I don't have any control over the quality of the internet. All right, so we'll continue. All right. So they don't want to define theta first. Right? So without evaluating theta, calculate the exact value in surd form if applicable, cos of theta. So I'm going to draw the triangle relating to that. I'm going to draw the triangle. Right? I don't have to draw the triangle. I can also use trigonometry to do it. Once they give you a trig ratio, the easy way to get the other trig ratio is to draw the triangle. So I'm going to draw a triangle, right angle triangle. This is my theta. Sine is opposite over hypotenuse. So my opposite is √5. My hypotenuse is 5. And I'm trying to work out this side using Pythagoras' theorem. So the x is going to be the square root of the hypotenuse squared minus this side squared. Well, this side squared is going to become a 5. If I were to write it, √5 squared. So that x becomes the square root of 20. That's what it is now, because that's 25 minus 5. Square root of 20. Square root of 20 is the same as 2√5. 1 was 2√5, because the square root of 20 is the same as the square root of 4 times 5. Square root of the 4 is 2. So it's 2√5. 2√5. So my x is 2√5. All right? So I can write it here. Let me write down in red so it becomes glaringly clear. All right? So I'm going to write the 2√5 right here. So this is 2√5 in simplest form. And therefore, my cos theta, you can just write it now, is equal to adjacent over hypotenuse. So it becomes 2√5 over 5. And that's it. Done. And I say leave it in surd form if applicable. So I'm leaving that. All right. Next thing I want is sine 2 theta. Now, what is this equal to? Sine 2 theta is equal to 2 sine theta cos theta. Again, if you can know this without having to figure it out in the exam, then you're good to go. But if you don't know this, how could we get it? We could get it from the formula sheet that they gave us. I'm just doing it this one time, and each time I come upon something new that you'll have to get from the formula sheet. If you don't know it, I'm going to show you how you do it. But I prefer for you to just know it. So that one came from this one, compound angle. And all that it is that we're using the plus, and the A is theta. If we were to write it, the A is theta, and the B is theta. So this is theta, and this is theta, and this is theta, and this is theta. So this is sine theta cos theta, and this is also sine theta cos theta, and this is a plus. And so there are two of them, 2 sine theta cos theta. That's what it is. But instead of wasting time to figure it out, it's better for us to just know that the sine 2 theta is 2 sine theta cos theta. Just know this. Just know it. You don't put that in the formula sheet. Just know it. Just as how we have to know that sine squared theta plus cos squared theta is equal to 1. And you also have to know that tan theta is sine theta over cos theta. You have to know these things, it's not on a formula sheet. Just learn the double angles because you have to use them. Just learn them. Just write them down on a card and practice writing them. Just learn them. Right? It's just a lot easier if you just learn them ahead of going exam to figure it out. All right? Because I see that they keep giving double angles a lot. Just learn the stuff that you need to use. All right? Learn the double angles. So back to the question down here. Where is it? Where is it? Right here. So we're basically now dropping the values in this. All right, going back for the blue. So it becomes equal to 2 times the sine theta is what they gave us, √5 over 5. So that's √5 over 5 And the cos theta, what we just found, 2 root 5 over 5. 2 root 5 over 5. Consolidate the values. 2 times 2 is 4. Root 5 times root 5 is 5. And they divide in these 5 times 5 under here. You can put 25 or we can keep them separate. Cancel one of them, and the final answer is 4 over 5. That is it. All right, 4 over 5. Anything else? Then I want us to prove this identity. Let's go. Prove this. To prove that this side equals this side. Now, I see they came from a tan expression. That's what a tan expression is. And they came to one expression with a cos. Generally speaking, we don't work with tan and cos and sin at the same time. So the first thing I'm going to do, I'm going to change this tan and write as sine over cos. All right? So this is what I'm going to get. I'm on the left-hand side, watch this now, equals. I'm going to change this tan squared and write it as sine squared theta over cos squared theta. Why is that? Because we should all know that tan theta is sine theta over cos theta. And whatever power this is raised to n, this is raised to the same power and the same power. This time is a square. So we have square here and square there. All right? Whatever power that is, that one is as well. So the tan squared is equal to this. Then we're adding 1. I'm not going to add 1. Why am I not going to add 1? So this one, I'm going to write it as cos squared theta over cos squared theta. Because I realize that the answer has one fraction. And if I'm adding this to 1, I need to make this a fraction with the same denominator as that. So I turn the 1 into cos squared plus cos over cos squared. Then because they have the same denominator now, I can consolidate the numerator and add them. So I end up getting sine squared theta plus cos squared theta on the numerator divided by cos squared theta. And we should all know that sine squared plus cos squared is 1. So this becomes 1 over cos squared theta, which indeed is the right-hand side. Quick and fast, nice and easy. They are very easy to do. But good with that?
Yes, sir.
But okay? All right. So that finishes that question. Question done. All right. Tricks on this paper done. Moving on to 2018. 2018 tricks. All right. After the tricks, we're going to go on to vectors. We're going to do trigs, vectors. Then we're going to do equations of a circle, coordinate geometry. Not coordinate geometry. So for 2018 now. 2018 now. Where are you? 2018. It's right here. I have to use the same Wi-Fi. Come on. 2018. This part of it is that. So here now, they want us to solve this equation and they only want us to go between 0 and pi, meaning they only want these two quadrants. All right? So any answer is going to place us in those two quadrants will work. So we don't want down here. We don't need any other quadrants down there. All right? Now, when I look at this, I see the double angle for cos right there, which is the most powerful double angle. This double angle for cos can be expressed in terms of sine square, which I see here. So it makes sense for us to use a double angle for cos that produces sine squared, which is this. Let's write over here. Cos 2 theta in terms of sine squared is 1 minus 2 sine squared theta. Let's shift this over. All right? We have to know that. And so I'm going to replace this with this. All right, and it's 3 times it. It's actually 3 times this. I'm going to do 3 times all of this. All right, that's what it is. And that's what I'm going to make my substitution. So this expression or this equation that they gave me will become, I'm going to write back this sine squared first. Let's zoom it up. So I'm going to have 3 times this. This 3 cos squared, and so it's 6 sine squared theta, and that is equal to 2. But can I understand that? Why do I go with that? This thing in red became this thing in red.
Yes, sir.
Good. Then that becomes a quadratic in sign. Quadratic in sign. I just need to transpose this 2. So if I consolidate these now, this and this is negative 5 sine squared. In fact, I'm going to transpose them over to that side. So that square term stays positive, right? So this and this is minus 5 sine squared. I'm going to transpose them onto the right side. So I'm going to get 5 sine squared theta. And then this 2, I'm going to transpose over here and subtract from the 2. Subtract from the 3, I'm going to get 1. And so I'm getting sine squared theta equals 1 over 5. But I understand that. What about that?
Yes, sir.
And then I have to square
Yes, sir.
both sides. I have to square both sides. But when you calculate square, you have to remember plus or minus. And so sine theta will be plus or minus. If I square root this, I can put as 1 over root 5, or I can square the whole thing and put the square root of 1 over 5. Don't matter, same thing. Now, this plus or minus, originally, if I was not restricted to the first 2 quadrants only, it would mean that I would want all the quadrants in this diagram. That's what it would mean. It would mean that I want where cos is positive here and there, and I would also, not cos, sine, I would also want where sine is negative here and there. That's where I would want. Just that this question restricted us to the first 2 quadrants only. But if they did not, if this was to say 0 to 2 pi, if this was 2 pi, then I would want all 4 quadrants. Okay? Because of the plus or minus. All right? But they are restricting us to the first 2 quadrants. So let me write it back. We only want the 2 quadrants where sine is positive right now. So we only want those 2 quadrants. All right, so it's the same process again. We need to find the alpha here. I already said that we want these 2 quadrants, and we want the alpha, and the alpha is going to be sine to the minus 1 of the positive of this, sine to the minus 1 of root 1 over 5. You're going to work that out in radians. So alpha equals what is it in radians? Somebody work that out for me, please. Sine to the minus 1 of 1 root 1 over 5, same as 1 over root 5. Root 1 over 5. What is that? Anybody?
0.46.
0.46. Give me 3 digits. 0.46.
4.
0.464.
Yeah.
0.464 radians. I'm going to put the radian symbol on it because it is not expressed in terms of pi. And so the angle that we want is only in the first 2 quadrants. So the theta, based on this quadrant diagram, means that I want this quadrant. I want the first 2 quadrants. This quadrant is pi minus alpha. So I want alpha and I want pi minus alpha. So my angle theta then becomes the alpha value, which is this. 0.464 radians, and also pi minus alpha 0.464 radians. If I wanted this quadrant and this quadrant, then naturally it will be pi plus and it will be 2 pi minus alpha. But we don't want those quadrants. Question did not request those two quadrants. The third and the fourth one, they did not request them, so I want to leave those out. And let's put this in the calculator for me, please, and get the answer. The theta is 0.464 radians, or what is this one?
2.676.
2.67 radian. All right, the three significant figures. That's it. All right, that finishes that question. Let's see if there's any other trick on it. Right, there's a proof on it. All right, so let me show you something now. So I want us to prove that this left side is equal to that right side. It's not complicated. I want you to remember something. All right, I'm going to show you something now that you need to remember. When you say 1 minus sine, 1 plus sine, or you say 1 minus cos and 1 plus cos, you have to remember this. You have to remember that sine squared theta is 1 minus cos squared theta. You know? This is the difference of two squares. It can be written as 1 minus cos theta times 1 plus cos theta. So these things, well, let me write the other one first. That's with the sine. With the cos squared theta as a subject, it will be 1 minus sine squared theta. That again is the difference of two squares. And so this can become 1 minus sine theta times 1 plus sine theta. So when I see these, I'm thinking that I want to bring them up to cos squared theta, or cos squared x in this case. I want to bring them up to cos squared x by converting them into the difference of two squares. So I need to adjust these to create the difference of two squares. All right? So let me make this smaller and start to work. All right. So these are things that if you're armed with these things in your head, then the questions become easier to do. All right, so I'm going to start with the left-hand side. I'm going to make the adjustments. So I need to get a 1 plus sine x beside this one. And I need to get a 1 minus sine x beside this one, so that I can form the difference of two squares. All right, so let's go. So my left-hand side is going to become, so this fraction, I'm going to multiply numerator and denominator by 1 plus sine x. I multiply under here by 1 plus sine x. For that first one. So my first fraction here, leave it, let me leave it. My first fraction here is going to become, when I make that adjustment, it's going to become 1 plus sine x over, and then this time this is the difference of two squares. Right? So it's going to become 1 minus sine squared x. And I'm subtracting. I'm going to do a similar adjustment to this. I'm going to multiply this one under here by 1 minus sine x. But I have to multiply the numerator also by 1 minus sine x. So my second fraction here, I put in a different color so it stands out. This one. Let's change it to purple. Didn't change. Let's go again. All right. So in purple is what I'm adjusting on this fraction. In red is what I'm adjusting on this fraction. All right. So I'm multiplying the denominator by 1 minus sine x. I'm multiplying the numerator by 1 minus sine x. So the second fraction becomes, shift this down. The second fraction becomes 1 minus sine x over, and then this times this is the difference of two squared, which becomes 1 minus sine squared x. But go to that. But
Yes,
okay with
sir.
that?
Yes, sir.
Good. This becomes equal to, because they now have the same denominator, we have to remember now, that this really is cos squared x, now this is cos squared x. Each of them is cos squared x, right? All right, so I'm adding numerator now, algebraically. So it is 1 minus 1, so the 1 gone. Then it's sine x minus a negative sine x. That becomes 2 sine x, because minus is plus. So I get 2 sine x on the numerator over this denominator, 1 minus sine squared is actually cos squared x. Tell me if you can answer that. But understand that? Let me write it over here.
Yes.
1 minus sine squared x is actually cos squared x. You have to know the three identities from left to right and from right to left. You have to know them both ways. When you know them both ways, the question becomes easy. Remember, this is what I'm working towards. So I see a tan right here, and I know that tan x is actually sine x over cos x. So I'm looking for sine x over cos x in this. Look how we're going to generate it now. Let me leave it. Let me leave it up here. All right. I'm going to generate it now. This becomes equal to, I'm going to split this sine squared, this cos squared. I'm going to write it as 2 sine x over this cos squared. I'm going to write it as cos x times cos x. And then now, right in the middle here, sine x over the cos x. That is tan x, That is tan x. Let me shift this cos x. But understand that sine x over cos x in the middle is actually tan x. And so this whole thing becomes 2 tan x, and this cos x remains on the denominator, cos x, which is the right hand side of it. See there? This is the right hand side. But understand that?
Yes, sir.
All right. This is quite easy. So remember, anytime you see 1 minus sine x, all you need is a 1 plus sine x beside it. Multiply them, and it becomes 1 minus sine squared, which is cos squared. Similarly, if you see 1 minus cos x, all you need is to multiply that by 1 plus cos x, which then becomes 1 minus cos squared, which then is sine squared. So look out for these expressions, all right? Look out for them in the proofs, and that's where we're heading towards. All right, beautiful. That finishes that question in 2018. These things are very easy, and they are much more easy if you know your trigger identity like the back of your hand. They're super easy when you know your trigger identity. It's super, super easy. So it makes sense to learn those trigger identities, have them in your head. Don't depend on a formula sheet. Put all the trigger identities in your head, right? And the questions will be very easy. Do not depend on a formula sheet for your trigger identities. And the questions will be very easy. Your brain will work like a computer and will tell you which one to use, right? Just like that. But you need to get them all in your head. The exam is Tuesday, and the more of them you can get in your head, you don't yet have them there, is the better. So I say go working on getting them in your head, the trigger identities. All right. This is a tricks question, and they're helping us. They're telling us these things which we all should know. So, for example, I know all of these things in my head. All right, I'm not depending on them to give me a call. What happens with these questions sometimes, guys, is that the trigger identities that they give you up here, there are a couple missing that you need to use in the question. That's what happens sometimes, right? There are a couple missing that you need to use in the question. So it's best you know all of them in your head. You should know the sine, cos, and tan for 30 degrees. Let me write them out that you should know. 30 degrees, 45 degrees, 60 degrees, 90 degrees, and 0. In terms of radians, this will be 0 radian. This is pi by 6, or pi over 6. This is pi over 4 or pi by 4. This is pi by 3. And this one is pi by 2. Then you should know the sine, cos, and tan for each of these. Know them on side, like the tip of the finger. Sine, cos, and tan for all of those, you should know. And the questions will be very easy. You don't have to depending on this to get them, if you know them in your head. Because it takes time to search for them, you have to use them. Better to know them all in your head. All right? Your brain has the capacity for all of them. All right. So they want us to, without using a calculator, we have to show that this thing equals that. All right? So what are we recognizing here? Let's look at it. This is a compound angle for cos. See this one? This one is a double angle for sine, you know. It's 2 times pi by 3. That's what this is, you know. This is 2 times pi by 3, you know. That's a sine double angle, you know. Like the sine of 2a, you know. That's what this one is, you know, on here. That's what it is. All right? So on the denominator, we have a double angle for sine. And on the numerator, we have a compound angle. So let's look at it. Remember, I'm writing this as the sine of 2 times pi by 3. So I'm using a double angle for sine. Let's write out the identity that we're using. Let's write them out up here. So I need a cos compound angle. This is a minus. I'm using this. Cos of A minus B. Expansion of a cos is cos, sine, sine. Cos, sine, sine. If I have a minus in here when I'm expanding cos, I must put a positive in between the terms out here. All right? So watch this now. This then is equal to, let's shift this over, the cos one. I'm just writing what we're using. This becomes equal to cos, sine, sine. Cos A, cos B. That's what I mean by cos. Since this is a minus, I need a plus between them. That's what happens when we expand the cos compound angle. Then I need sine. Sine A. Let's write that better. Sine A, sine B. That's what I mean by sine. So it is cos, sine. If I have minus here, I get a plus there. When I expand the cos compound angle, the sign is reversed outside. Then this now is sine 2a. This is really the sine of 2a, which is 2 sine A cos A. That's what this is, you know. 2 sine A cos A. In this case, the A is pi by 3. So these are the two identities I'm using on here. And it becomes very easy. It is super easy. Super easy. So the left-hand side becomes equal to, I'm doing this one first. Using cos, sine. Watch this now. It becomes cos pi by 4, cos pi by 3. This is a minus, I need a plus. Then I'm going sine. Sine pi by 4, sine pi by 3. That's the numerator now. I just worked out the numerator. And I'm dividing that now by this. And I'm using this identity. 2 sine A cos A. So it's 2 sine pi by 3 sine cos pi by 3. That's what it is. I'm treating this as if it is 2a, sine of 2 pi by 3. But understand that so far? But okay with that so far? Still there?
Yes, sir.
All right. And then when I'm dropping the values now. And if you know these things, you don't have to search for them up here. Let's see if there's any missing. Well, I give them to you. The pi by 3 and the pi by 3 and the pi by 4. So this time I give it to you. But sometimes I don't give you all of them. All right? But it's best to just know them in your head. Don't waste time searching for them. Cos of pi by 4 is root 2 over 2. Root 2 over 2. This is 60 degrees. Cos of 60 degrees is a half. Plus the sine of 45 degrees. That's 45 degrees. Sine of 45 degrees is root 2 over 2. This is 60 degrees. The sine of 60 degrees is root 3 over 2. Divided by 2 times, that's a sine of 60 degrees again, which is root 3 over 2. And the cos of 60 degrees right here is a half. Pi by 3 is 60 degrees, which is a half. Cos of that is a half. That's what you're working on. I basically just consolidate your values now. I can do this quickly by recognizing that I have a 4 under here and a 4 under here and a 4 under here. So if I go and multiply the numerator by 4 and the denominator by 4, it will cancel out these denominators for me. That's what these 4s will do. Cancel out the denominators for me. All right? So I'm working only with the numerators now. So it becomes equal to, this becomes just root 2. Root 2. This root 3 times root 2 times root 3 is root 6. Root 2 times root 3 is root 6. Remember the denominator gone, you know. 4 cancel them out for me now. So the denominator gone. So that becomes plus root 6. And then this denominator gone. All I'm left with now is 2 root 3 times 1, which is 2 root 3. So I get a 2 root 3 under here. And when I check that, that is what I have up here. That's my right hand side. Equals the right hand side. So that was shown. Or we can say quite easily done. We can say quite easily brushed aside. I'm just having some fun with that one. But you can write this one. I can write this one. All right, that's it. Any questions there? Any questions there? Trigonometry is super easy when you know the more things you know. The problem that people have with trigonometry is that there's too many things that they don't know. That is the problem with trigonometry. You know your identities, you know your trig angles, the 30, the 45, the 60, the 90, you know the sine and cos of them, you know the degrees in radian form, I know the radian form in degrees for those angles. Questions, they are like super easy. So trigonometry is really a no problem topic. If you take the time to learn those trig identities and learn those trig angles, sine, cos, and tan of those trig angles. I'm about to go to this. Oh, there's another proof right here. I want us to prove this one now, that this is equal to that. Ready? Very good?
Yes, sir.
All right. So here now, I see I have 2 values and they're given 1 single value. So I need to consolidate these into one term, right? So there's not one way to do it. There are multiple ways to do it, right? I can recognize this. That is going to become the difference of 2 squares right off the bat. It's going to become 1 minus sine theta times 1 plus sine theta. And then it's going to cancel with this. And then this one is going to eliminate this one and it's done. I can see right through it already because I know the identities. That's one way to do it. Or I can change this to 1 plus sine theta over 1 plus sine theta and still expand this out as 1 minus sine squared theta. And it will work itself out again. But I'm going to do it the easy way, which is to change this cos squared. Let me write over here what I'm going to use. Oh, yeah. So I'm going to use that cos squared theta can be written as the difference of 2 squares. Firstly, it is 1 minus sine squared theta. And then this is the difference of 2 squares, which then is 1 minus sine theta times 1 plus sine theta. So I'm going to replace this cos squared with this guy down here. So, and it will fall out like an apple from a tree. Nice and easy. So the left-hand side becomes 1 minus this numerator is going to become 1 minus sine theta times 1 plus sine theta. And they would have seen where this comes from because I would leave this on my exam paper or leave it there. I'm not going to take it off. I would leave it on the exam paper. Divided by 1 plus sine theta. And then these two cancel each other. This cancels with that. And so I am left with 1 minus bracket 1 minus sine theta. Because I'm just getting that. These gone. These cancel out and gone. Cancel out each other. And then when I expand this, 1 minus 1 that gone, then minus a negative sine theta gives me sine theta. And that is the right hand side. Done. It's not complicated when you know your identities. Simple as that. But okay?
Yes,
Very
sir.
good? Good. So you're seeing, guys, that you need to learn your identities. Trigonometry will always be a problem if you don't take the time to learn your identities. The basic ones like these over here. These should be in your head, tip of your finger. All right? Questions are super easy. Super easy once you know those identities. So your challenge is to study and learn those identities. That's where your problem is. If you have a problem in trigonometry, that is where your problem is. The lack of knowledge of the trig identities and the trig angles that you're supposed to know. The more things you know in trigs, the easier questions will be. I'm emphasizing that because I want you to be motivated to go and study those trig ratios. Study them, learn them, get them in your head. Don't depend on any formula sheet for them. Put them in your brain. All right? Put them in your brain. Don't need any formula sheet for them. All right. So this is 2016. Looking for the trigs question on 2016. This is vectors. All right. This is circular measures. We're going to come back to this. All right. Here's a trigs now. Right here. Now, let me bring up another side of the screen so that we can work over here. And then let me do it over here. We're going to have to be writing on those lines. I prefer to write on the blank page, the blank space. All right. So this question says now, let's look at it. It says, that's this one. It says they are telling us that sine of 30 degrees, which you should know, is root 3 over t. They don't have to tell me this. I know this, right? They don't have to tell me this. Sine of 45 is root over 2. Without use of a calculator, evaluate the cost of 105. You see the problem here now? It's 105, you know. They gave us 30 and 45. You know. So the question is, we have the cost of 105 degrees. 105 degrees. We want to write this 105 as a compound angle. They gave us 30 and 45. Now, how are we going to use 30 and 45 to break down the 105? If you try to use the 30 and the 45 to break down the 105, you're going to run into problems. Because 105 is easier to work as 60 and 45 clearly. But the point is they did not give us the cost for 60 or the sine for 60. See, they're not going to give you everything. So the best thing is to do is to know your stuff. But understand that. So what does that mean here? The angle that they gave me, the 30, is not very useful for this angle that we need to find. Because 105 is easily broken down into the two angles, the two principal angles are the two angles that you're supposed to know. It's a 60 and a 45. So I'm going to use that. Cos, sine, sine. Cos, sine, sine. So this becomes equal to, this side becomes equal to now. Cos, sine, sine. I'm expanding the cos function. Cos, sine, sine. I don't need no formula sheet for that. So it's cos 60 degrees, cos 45 degrees. Since this is a plus, I have to put a minus between them here. Then it's sine, sine. Sine 60 degrees, sine 45 degrees. Notice they did not give me anything for 60 degrees in the question. So you have to know it. This becomes equal to the cos of 60 degrees is half. Cos of 45 degrees is root 2 over 2. Again, they gave me 45 and they didn't give me the cos of 45. So you have to know it. They didn't give me this one. They didn't give me any of these. Minus. They didn't give me the sine of 60. The sine of 60 is root 3 over 2. And the sine of 45 is root 2 over 2. Now, some people are going to waste time and search for these in the calculator. You don't have to search for those in the calculator. Those are standard angles that you must know. This becomes equal to, this is root 2 over 4 minus, this is root 6, because root 2 times root 3 is root 6. Root 6 over the same 4. Since I have the same denominator, I can consolidate. Root 2 minus root 6 all over 4. And you can, if you have one of those calculators that will give you the answer in this form, you can put your calculator in degrees and work this out. And it should give you this exact thing if your calculator is one that can give you inserts form. Hopefully that's one that you have. So you can check it for me. Check it for me, Kyle. Cos of 105, but make sure that the angle, the calculator is in degrees when you do it. Cos of 105 degrees. Put the calculator in degrees. You get this exactly on the calculator, don't it? Good. So give it as this. Give it as minus root 6 plus root 2 over 4. It's the same thing. This is what the calculator gave. It's the same thing. All right? So that is correct. Next question. This one to prove this one. Let's go. To prove that one. Again, we want to know the trigger identities. First thing I'm going to do, say we're getting back at 10. You have to know that this one is really sine theta over cos theta. And this one is really sine alpha over cos alpha. And that plus. So that's what you're really proving. You want to go from this to this initially. You know? That's what you're really proving first. All right? We're going to use a compound angle. So this one, we're going to use the left-hand side. So the left-hand side equals expanding the sine compound angle. Expansion of sine is sine cos, cos sine. Sine cos, cos sine. When you expand the sine compound angle, it is sine cos, cos sine. What do I mean by that? I mean sine theta, cos alpha, sine cos, cos sine. If this is a plus in a compound angle, when I expand in the sine compound angle, I'm got the same positive out here. Then I'm going to do cos sine. Sine cos, cos sine. Cos theta, sine alpha. That's what I get when I expand this. Then here I'm going to put back the cos theta, cos alpha under here. Cos theta, cos alpha. What does this mean? I said I break them out into two separate terms. What it means, you know, is that I divide this by that denominator, and then I divide this by that denominator separately. So I'm going to get sine theta cos alpha over the denominator of cos theta cos alpha plus, then it's this one divided by this one. Cos theta sine alpha over cos theta cos alpha. And it falls out like an apple from a tree. Because this cos alpha cancels this cos alpha. And this cos theta cancels this cos theta. And you can see that we end up with sine theta over cos theta right there, which is tan theta, plus sine alpha over cos alpha right there, which is tan alpha, which is the right hand side shown. Got to go to that? But okay?
Yes, sir.
All right, beautiful. These are super easy questions. All right, 2016 done. Let's jump to 2015. More maths equals better maths. More maths equals better maths. So 2015 now. Where are you? 2015. 2015 is right here. 2015 trigs. Let's go. Looking for the 2015 trigs. This is circular measures. I said 2015 trig on or something. Down here. Right here is 2015 trigs. All right. So this one we're working in degrees, guys. So working in degrees. We're gonna work in degrees. I think the new syllabus will be working on the radians, but we do it in degrees still. We don't know, eh? They want us to solve this. I want us to solve this. Now, right off the bat, I say cos theta here. I can't change this enough. I can change the sine squared. Because I know that the sine squared is the same as 1 minus cos squared. So I can turn that equation into a quadratic in cos. Right? That's what I'm going to do. So I'm going to write about the equation first. It is 8 sine squared theta equals 5 minus 10 cos theta. I'm going to use that sine squared theta is 1 minus cos squared theta. That's what I'm using. I'm going to use this. And this is 8 of them. So let me say 8 of this is 8 of this. All right? So this equation right here becomes 8 of this. So it becomes 8 minus 8 cos squared theta equals 5 minus 10 cos theta. That's what we get. So we know about quadratic in cos theta. It's a quadratic equation in cos theta. Quadratics are easier when the square term is positive. So I'm going to transpose everything over onto that side to get my square term positive. So when this goes over there, it becomes a positive 8 cos squared. I'm going to write 8 cos squared theta. This is already over there as a negative 10 cos theta. And then this 5 minus this 8 is giving me a negative 3 equals 0. So that it equals 0 is on this side, equals 0. But I'm going to write it on this side, as it's the same thing. And then I've got to solve. Now, that time we factorize. Let's see, it's a quadratic in cos. Let's see if we can factorize. Looks easy to factorize. Factors of the 8 is 4 and 2. I can put the 4 with the 3 to make 12. 12 minus 2 is the middle term, 10. So I want to write 4 cos theta and 2 cos theta. I'm going to put the 4, the 3 over here to make 12 and put the 1 here. And this is 2. 12 and 2, the difference is 10. All right? That's what the factorize into. This tells me that the 2 signs in the bracket are different. This tells me the larger product, the negative sign. The larger product is the far product, that is 12. Make it negative. So I'm going to put the negative here, put the positive there, equals 0. That is what it is. Then I'm getting from this factor, I'm getting cos theta equals a negative quarter. From this factor, I'm getting cos theta equals 3 over 2. Let's zoom that up. 3 over 2. Now, this cos theta equals 3 over 2 is not valid because it is 3 over 2 is 1.5, greater than 1. Cos can only go, cos of an angle can only go between negative 1 and 1. Because the cos graph goes like this. Start up at negative 1 and go down to negative 1. This is a cos theta graph. All right. Same thing with sine graph. The sine graph goes like this. Goes up to negative 1, goes up to 1, goes up to 1, and goes down to negative 1. That's sine theta graph. So sine theta and cos theta cannot go outside of negative 1 and 1. All right? The sine theta graph and the cos theta graph. If I double this and put 2 cos theta, then this goes up to 2 and go down to negative 2. Because the cos part alone goes up to 1 and goes on to negative 1. Right? So be mindful of that. So this part of it has no solution over here. So I'm going to write not valid. Not valid. And so I'm really only solving this. I'm going to draw the quadrant diagram for that. Each time you're solving a trig equation, I want to always bring it down to cos theta equals a number, or sine theta equals a number, or tan theta equals a number, and then you draw the quadrant diagram based on whether the number is positive or negative. That's how you want to solve your trig equation. Bring them down to one of these. So simplify them down to one of these. Then you draw your quadrant diagram. So I want the quadrant where theta, where cos of theta is negative. So I'm going to draw the quadrant diagram. I'm going to mark where cos is negative. Now, cos is positive here and there. And so the angles we want is where it's negative here and here. But I have to find my principal acute angle first. So my principal acute angle is cos to the -1 of the positive quarter. Remember, it's at the positive quarter because the angle is acute. So you have to do cos to the -1 of the positive value, which is a quarter. Write that out to the character for me, please. After we finish the trigs, we're going to take a break. Right? We're going to go down to 2012, 14, 13, 12. So 3 more questions and we'll take a break. What is work out to? Cos to the -1 of a quarter. We're working in degrees. Working in degrees. We're working in degrees. How much is it?
75.52.
75. That's 75.5. That's 3 digits plus this 1 decimal place. So this will satisfy your answer. Usually we're given answers that are not exact. We give them the 3 significant figures. In the case of degrees, you give them the 1 decimal place. In fact, the question did say 1 decimal place right here. Right? So 1 decimal place. So anyway, so that's the principal acute angle. So the equivalent angle in this quadrant, since we're working in degrees, it's going to be 180 degrees minus alpha. And this one down here is going to be 180 degrees plus alpha because we're working in degrees. So our theta angle that we want in this quadrant is 180 degrees. Let's mark that properly so that better. Is 180 degrees minus the 75.5 degrees. And in this quadrant is 180 degrees plus the 75.5 degrees. I can just work these out for me, please. 180 minus and 180 plus. What are they?
One hundred and 4.5.
104.5 degrees. And over here, what is it over here? This one?
255.5.
255.5 degrees. That's it. We're going to do this nice proof right here. This proof. Let's look at it. Let's look at it. It said to prove that this side is equal to that. So basically, I want to simple. Remember now that this is really sine theta over cos theta. You know? So in essence, this thing is supposed to reduce the sine theta over cos theta. All right? So I'm going to use trig identities. All right? Trig identities. So let's look at what we have. So I have a double angle here, and I have a cos double angle here. Now remember, this one is very powerful. You know? It can be written in 3 ways. I have to be smart. Because I see the one here, I want to use the one that has the -1 in it. The one with the -1 in it. I have 3 options for this, you know. Because I want to eliminate that one that is here in this expression. I don't remember, and I want this to just come down to sine theta over cos theta. You know. So I don't want this one. So I'm going to use a double angle for cos that will help me to eliminate this one. So therefore, I'm going to use for this one, I'm going to write it as 2 cos squared theta. 2 cos squared theta minus 1. That's the one I'm going to use. Because this minus 1 will eliminate this. And this up here is 2 sine theta cos theta. 2 sine theta cos theta. You have to know your compound angles. So those are the 2 changes that I'm going to make. All right? And then it will fall out like a tree, like an apple from a tree. As usual. Nice and easy. So the left-hand side of this expression will become, this remains unchanged, sine theta. Plus, this double angle for sine becomes 2 sine theta cos theta divided by, this remains the same, 1 plus cos theta. And then I've strategically chosen this one to use. Remember, the cos 2 theta is very powerful. It can be written in 3 ways, where you be smart and use the one that will help us to move this one. So we're using the 2 cos squared theta minus 1 first. That's what we're using. If this had a negative 1 in it, if the expression had a negative 1 in it, then I would have used for the double angle, I would have used the one with the positive 1, which is 1 minus 2 sine squared theta. Right? And then these will eliminate each other to the negative 1. All right? But that's what we have. So this one wipes out this one. And so let's look at it now. The numerator can be factorized with a sine theta. But I can say that the numerator can be factorized with a sine theta. So I'm going to write it as sine theta into 1 plus 2 cos theta in the numerator. And then on the denominator, I really only have these two things left now. These two things. This gone and this gone. Then they're gone, you know. So I need to factorize cos theta out of these two. So if I factorize cos theta out of those two, I'm going to get cos theta bracket 1 plus 2 cos theta. But I can say that on the denominator as well. But I can say that.
Yes, sir.
Good. And then what happens is that this cancels this, and I'm left with sine theta over cos theta, which is my tan theta. So you see they usually take about 3 lines, 4 lines the most. So if you find that you're taking 6, 7, 8 lines, it means that you're going around in circles. You're not doing it properly. You usually take about 3, 4 lines to finish. All right? See, 3 lines and it's done. So if you're going 6 lines, 7 lines, and you're going around in circles, then you're in 6, 7 lines means that you're going around in circles. But this thing will be very easy when the trig identities are in your brain. So you need to get those trig identities in your brain. You see exactly what you need to do. That's the first thing for these questions to be easy. Get the trig identities in your head. That finishes this question. Let's go down now and do 2014. 2014. 2014 paper. More maths equals better maths every time. 2014. Where are you? 14 is right here. All right. Let's go. Looking for the trigs. This one is vectors. All right. This is trigs, but this part of it is circle measures. This is circle measures right here. So we're really doing this part on this now. All right. So we're doing this. We're doing this question. Now doing this proof. All right. Those are the 3 questions on this one. Ready? See again, they give us this. You should know pi by 6 is 30 degrees. Sine of 30 degrees is a half. Cos of 30 degrees is root 2 and 2. All right. They said, show that this thing is equal to this thing. So this is the left side. So basically, we're going to expand that and must get this one done. This one is pretty straightforward, right? So the left-hand side, we're going to start with the cos of x plus pi by 6. Expansion of cos is cos, cos, sine, sine. Cos, cos, sine, sine. Cos, cos, sine, sine. We expand the cos function, cos compound function, cos compound angle. Cos, cos, sine, sine. Because this is a plus, I'm going to get a minus between the terms out here. Simple as that. So I'm going to get cos x, cos pi by 6. That's my cos, cos. Minus sine, sine. Sine x, sine. All right, I don't know the space. It's like a smaller. I'll shift them over. Let me shift this over. So sine x, sine pi by 6. So see, cos, cos, sine, sine. When you find the cos function, that's what you get. Cos, cos, sine, sine. Easy way to remember it. Plus inside here, minus inside here when you do the cos. If it was a sine function, whatever sign is in here, you get the same thing out there. Ready now, dropping in the values now. Equals the cos of pi by 6. Pi by 6 is 30 degrees, you know. Cos of 30 degrees is root 3 over 2. So this becomes root 3 over 2 times cos x. So I'm getting root 3 over 2 times cos x minus. This is sine of 30 degrees. Sine of 30 degrees is a half. So I'm getting a half times sine x. A half times sine x. A half times the sine of x. Look at what they want me to prove. They want me to prove this. What they have done, they have factorized a half from those two terms. They have factorized a half from the two terms. So if I factorize a half, I'm going to get the root 3 cos x left here. Root 3 cos x. And I'm going to get the 1 sin x left there. So it's minus sin x left there, which is the right hand side. Done. That's what they told us to prove right here. Easy. What an easy question. How can somebody say trigonometry hard? It's easy. Easy. Let's do this one now. Let's go. The proof. Now look at this proof now. I want us to prove this one now, right? Right inside here. First thing, you don't work with tan, sine, and cos at the same time. So first thing I'm going to do is replace that tan and put that sine over cos. No, I don't have to put that sine over cos right here, like so. I don't have to put like sine over cos right here. Sine theta over cos theta. I can put it like this. I can put the sine theta up here and put the cos theta down here. They still make the tan theta. That's what I'm going to do. All right? So let me go and do it now. So the left-hand side. Why am I doing that? Because I see a cos on here. You have to observe what they're trying to get to this. Right? So I'm going to go and write this as boom, bang. Left-hand side. Left-hand side, which is this side. I'm going to write it as equal to sine theta times sine theta over cos theta bracket 1 minus cos theta. That's what I'm doing. This is what was the tan a while ago. That is the tan. Good? Then I realize now that this becomes a sine squared. And then this minus 1 minus cos is a part of, right now, is a part of the difference of two squares. Right? Which is 1 minus sine, 1 minus cos times 1 plus cos, a part of the difference of 2 squared. But I can get it out of this sine squared up here. I don't have to touch this, it will cancel out. All right? So let's go. This becomes equal to, this becomes sine squared up here. Sine squared theta over cos theta into 1 minus cos theta. I'm not going to break this because, as I said, it's part of the difference of 2 squares. I'm going to expand this and write as 1 minus cos squared. So it's 1 minus cos squared theta over cos theta into 1 minus cos theta. Then this now the difference of 2 squares. So it becomes 1 minus cos theta times 1 plus cos theta over cos theta bracket 1 minus cos theta. And voila, these cancel each other. This cancel with that. I'm doing more steps that I need to show them, but just that I want to show the steps. I could have gone much further, much quicker. And so I'm left with this divided by this. I'm going to show it. I don't have to show it, but let me show it still. Becomes equal to 1 plus cos theta all over cos theta. So it means that I'm dividing the 1 by cos theta, where I get 1 over cos theta. And I'm also dividing cos theta by cos theta, which gives me a positive 1, which is the same thing they have right here, because I have them all the way around. So I can say which is the same as 1 plus 1 over cos theta, which is the right hand side. I've not done anything magical in this proof. Right? It's all straightforward. I've not done anything magical in it. That is it. Right? So you see, guys, This trigonometry topic is easy. It's easy because I know the trig identities like that at the tip of your finger. Right? When you know the trig identities, that are just easy. So if you want this topic to be as easy, learn the trig identities, please. All right, 2013 and 2012, and we'll take a break. 10 minutes break. All right, 2013. Looking for the trigs. All right, so the trigs right here on 2013. This is it. So this is the first part of it is circle. Circle measures up here. And then we're doing down here now. We're doing this one. And we're doing this one. This one. All right, let's go. Let's go. First one is this one. This one. Let me write it out over here so we can look at it. It is saying we are solving 2 cos squared theta plus 3 sine theta equals 0, and we're going between 0 and 360 degrees. I think the example you're doing 0 and 2 pi now, so I think I'm going to do 2 pi. So even though it says 0 to 360 degrees, I'm going to do 2 pi, 0 and 2 pi, but the syllabus is in radians now. Remember, guys, now, you can't change sine theta, but you can change cos squared. Because remember, cos squared is 1 minus sine squared. So let's write it out. What we're going to use? We're going to use the fact that cos squared theta is the same as 1 minus sine squared theta. That's what we're using. And it's 2 of them. It's 2 of this. So basically, it's 2 of this. We're going to replace this with 2 of it. 2 of this. All right? That's what it is. So it means that this expression right here, this expression becomes 2 of this, because it's 2 cos. So it becomes 2 minus 2 sine squared theta plus this 3 cos sine theta, 3 sine theta equals 0. So that's a quadratic. I like when my square term is positive. I'm going to multiply through by -1 to get my square term positive. When you're doing trigs, when you're doing quadratics, it's always easier when the square term is positive. Negative square term, you tend to make mistakes. So I'm going to multiply through by -1. This becomes a positive 2 sine squared. It becomes a negative 3 sine theta. This becomes a negative 2 equals 0. That is a quadratic in sine. That's just a quadratic equation, but it's in sine theta. Can we factorize? That's a prime and that's a prime. When n values are prime numbers, it's easy to factorize. Bam, 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 bam equals 0. Factors of this are only 2 sine theta and sine theta. I want my middle term to be 3. Factor of this is 2 and 1. And I have to put this 2 with the 2 over here to make it 4. And then 1 here to make it 1. 4 minus 1 is 3. And I'm subtracting because the last term is a negative. So I know that I'm subtracting the far product and the near product. Signs are different. I have to give the greater product the negative sign. The greater product is the far product. The far product is the greater product. It's 4 times. So make it negative and make this positive 1. Positive. That's it. This factor gives me sine theta equals -1/2. This factor gives me sine theta equals 2. Again, this sine theta is outside the range -1 and 1. So therefore, this part of it is not valid. Sine of an angle can only be between 1 and -1. So this is not valid. So you see this multiple times, you must know it by now. So we're only solving this. So when you draw the quadrant diagram, once you get down to sine of an angle equal a value, you draw the quadrant diagram for that. And you mark where you want sine of an angle is negative. Sine is positive here and there. You want where it is negative. So the two quadrants you want are here and there. But you have to find the principal acute angle first, the alpha. Now, I know it's 30 degrees off the bat, because the sine of 30 is a half. 30 degrees is pi by 6. If I'm working radians, it's pi by 6. If you don't know, you have to do sine to the minus 1 of the positive value, guys, remember, of the half. Working in radians. So if the question said degrees, you're going to work in radians, because I think your syllabus is working in radians. It's pi by 6. Hope you have a calculator that will give you the pi by 6. Because if the answer can be expressed in terms of pi, CSEC will want to see it in terms of pi, because after all, the syllabus says you are to know these angles and values. All right? So once it's one of those angles you're getting, pi by 6, pi by 3, pi by 2, pi by 4, CSEC wants to see it. They don't want to see the decimals. And they work in this quadrant, which is pi plus the alpha, and this quadrant, which is 2 pi minus the alpha. So then we can write our angle. Our theta becomes this quadrant first is pi plus the alpha, which is pi by 6. And this quadrant is 2 pi minus the alpha, which is pi by 6. And so we can consolidate now. This is the same as 6 over 6. That becomes 7 pi by 6. So that's 7 pi by 6. And this one is the same as 12 over 6. So it's 12 minus 1 is 11. That becomes 11 pi by 6. So it's 11 pi by 6. So those are my answers right there. Very good.
Yes, sir.
Very good, that?
Yes.
All right. Beautiful. Then we'll come to this next part now that I'm leaving shaded in red right here. Let's see what it says. It says, given that the tan of theta minus alpha is a half, it's a compound angle now. I'm going to expand it out. And that the tan of theta is 3. Now, when we expand this out, the tan of theta is going to be in there. We're going to see the tan of theta in there. We're going to replace it with a 3. It says, use an appropriate compound angle. Appropriate compound angle is one for tan. Right? To find the value, to find the acute angle of alpha. So in other words, we're trying to find alpha. So basically, helping us to set up an equation and solve for alpha. I'm going to start with this and expand it out. Let's say use an appropriate compound angle. What compound angle are we use? We're going to use this one. That the tan of A minus B, that's going to be on the formula sheet, is tan A minus tan B over 1 plus. When you have a minus here, you have a plus here. When you have a minus here, you have a C minus here, and you have the opposite sign on the day. You can look at the trig identity that you want. And then this becomes tan A, tan B. You need to know these things. So all that happens is that this is A, theta is A, and alpha is the B. Or you can say B is alpha. All right, so I'm going to set it up now. So the left, this, I'm going to write out this. So they're telling me that the tan of theta minus alpha is a half. I'm going to expand this out. They're also telling me, let's put it here, that the tan of theta is 3. And I want the mom to find alpha. So I'm going to expand this out first and then drop the tan theta, then for the tan theta. All right? So expand this first. I'm going to get tan theta minus tan alpha over 1 plus tan theta times tan alpha, and that is equal to half. Then this tan theta and this tan theta, I'm going to drop the 3 on it here and there, because tan theta is 3. Right? So I can say, therefore, 3, that's what this is, minus tan alpha over 1 plus, this again is 3. So it's 3 tan alpha is equal to half. So now I have an equation in tan alpha to solve. And I can solve it easy by cross multiplying. This denominator I multiply it up here, and this denominator I multiply it up there. Cross multiply. Some teachers go like that. All right? So already know. So I'm going to cross multiply. So this 2 is going to multiply up here. It's going to give me 6 minus 2 tan alpha equal this denominator multiplied up here by the 1, so it stays as it is, which is 1 plus 3 tan of alpha. Then I'm going to consolidate the values. This negative 2 comes over here, add to the 3, give me 5 tan alpha. So I'm going to get 5 tan alpha over here equals this 5 comes over here and subtract from the 1, subtract from the 6. 6 minus 1 is 5. If we divide both sides by 5, we're going to see that tan alpha is actually equal to 1. And if tan alpha is equal to 1, it's tan of 45 degrees, that's equal to 1. So my alpha is equal to 45 degrees. If we work it in degrees, or work it in radians, it is pi by 4. If you don't know, then you will have to go in the calculator and go alpha equals tan to the minus 1 of 1. Why am I not drawing a quadrant diagram? Because the question said all I want was acute angle. So I don't need multiple angles for this one. It's asking me only for the acute angle, which is the alpha. Same alpha that we would have in the quadrant diagram here. All right, that's all it wants. Just only the acute angle. All right, so that angle is actually 45 degrees, working in degrees, or pi by 4 radians if you're working in radians. That's it. Very good.
Yes, sir.
Yes, sir.
All right, one more and then we break. We're gonna take a short break, 10 minutes. We don't need more than 10 minutes. All right, short break. Josh, you good? Mr. Darling.
Yes, sir.
Okay, Mr. Hutchins, what's up?
Okay, sir.
Where's Otania? And where's Antoine? I don't see test either. Anyway, it's being recorded, so hopefully they'll get it later. I know they have other classes, so maybe they'll go on to another class. Anyway, 2012. Doing all of them for you. All right, all of them. So anything I'm coming with, I'm gonna shut it up. Shut it up. And these things are soft. The capital T. Very easy stuff. Very easy stuff. This one right here now. This is 2012. All right, 2012. So this part of it first. This one first. So give us these things again, but I tell you, it won't depend on them because sometimes some of the information is missing. They're giving us all of these. Sorry, they're giving us all of these things. But if you know them in your head. It says, without using a calculator, they want the exact value of the cos of 7 pi by 12. Let's look at it. They want the cos of 7 pi by 12. They could have just asked me for this straight, you know, without giving me all of this. Cos of 7 pi by 12. So you want to be able to use your pi by 4 and your pi by 3. So that 7 pi by 12, we're going to break it down. All right? So you're going to go like this. And so, okay, the cos of 7 pi by 12 is the same as the cos of 3 pi by 12 plus 4 pi by 12. Got the 3 and the 4 give me the 7. And then now this part cancels down to pi by 4. And this part cancels down to pi by 3. That's what it is, you know. And so I'm doing expansion for cos, which is cos minus sin. Cos minus sin. So you see these questions repeat, guys. Almost the same thing. They repeat them. Easy. Cos minus sin. So this becomes equal to cos pi by 4, cos pi by 3 Since I have a minus, since I have a plus inside, I have to put a minus out here. Then it's sine pi by 4, sine pi by 3. When it's called a cos compound angle, it becomes cos cos, sine sine. Cos cos, sine sine. Learn it in your head. If you have a plus in there, you're going to get a minus out here when you expand the cos compound angle. Sign is reversed in between the values. Then now drop them in. Cos of pi by 4 is root 2 over 2. Because that is a cos of 45 degrees. Cos of 60 degrees a half. This is 60 degrees. Pi by 3 is 60 degrees. Remember that the pi is 180, you know. So 180 over 3 is 60. So pi by 3 is 60. Cos of 60 degrees a half. You need to know those things. You don't need to pull out no calculator to do this, to work them out. Have them in your head. Minus the sine of 45 degrees. Pi by 4 is 45 degrees. That's root 2 over 2. Learn them. Make them stick in your brain. This is 60 degrees. Sine of 60 degrees is root 3 over 2. Root 3 over 2. This becomes, every denominator now is 4. This is root 2 times 1 is root 2. This is minus root 2 over 4 minus, this is root 6 over 4. Root 6 over 4. Same denominator, so we can consolidate. Root 2 minus root 6 all over 4. That is my answer, exact form. Don't put no calculator on it. That is it. All right, next question down here. Now, this question was the first exam paper that I said for ADMATS, and they made a mistake. They put a sec right here. Now, sec is simply 1 over cos theta. When I used to do ADMATS, I used to have to know these things. I used to have to do sec, cosec, and cot. But those not on your syllabus anymore. So I'm still going to do the question, you know. Just that I'm going to replace this sec with what it is. The sec, you don't know, but I'm telling you, it is 1 over cos. Or maybe you do know. It's 1 over cos theta. That's what the sec is. So I'm going to prove that this side is equal to that side. Nice and easy. So I'm going to start with the left-hand side and see. Let's say that, let's write what they gave us. 1 over cos theta plus tan theta. That's what they gave us, right? The first thing, as I said, notice the answer only have sine and cos in it. You don't work with tan, sine, and cos. So the first thing you want to change is that tan. Tan is sine over cos. Tan is sine over cos. So this becomes equal to 1 over cos theta plus, and then this tan is sine theta over cos theta. So these two fractions now have the same denominator. So I'm going to write as a single fraction. It becomes 1 over 1 plus sine theta over cos theta. And so we are doing the reciprocal of a fraction. We just need to write it as a reciprocal of a fraction. So it becomes equal to cos theta over 1 plus sine theta. All right. Now, when I see this, I'm thinking the difference of 2 squares right off the bat. What's the answer I'm trying to get? I'm trying to get this. All right. So the 1 minus alpha sine theta there. So it confirms what I'm going to do, because I have 1 minus sine theta in the numerator. To generate my cos squared under there, which is the same as 1 minus sine squared times 1 plus sine squared. I'm going to multiply this equation here by 1 minus sine theta and 1 minus sine theta on here, such that these two on the denominator, they become the difference of 2 squares. That's not the only way to do it, but that's the way I'm doing it. All right, that's the way I'm doing it. I can show you another way to do it. I'm going to show you another way to do it from here. All right, so when I do this now, these two becomes the difference of 2 squares. So I'm going to get cos theta bracket 1 minus sine theta all over. This now becomes 1 minus sine squared theta. And 1 minus sine squared is cos squared. So then it becomes cos theta bracket 1 minus sine theta over cos squared theta. And there you see it. One of the cos theta here cancels out one of them there and get the result that they gave us, which is 1 minus sine theta over cos theta. That is the right hand side. Now this I'll show you another way to work from here. Now let's say we have gotten to here. I'll show you another way right here. Let's say we have gotten to here. Copy. I'll show you another way you could have done it to completion. I'm going to paste that here. So let's say we have gotten to here again. All right. And when I look at the answer over here, I see a cos theta on the denominator. Notice? I see a cos theta on the denominator. I can adjust this thing and adjust on the cos theta on the denominator by multiplying. Let me shift this equal sign here. You can see it better. I can multiply the denominator by the cos theta to get the cos theta that they have, but multiply by the numerator by cos theta. You can do that, bracket up this. All right, and then what happens now is that this up here becomes cos squared theta. So it will become cos squared theta over cos theta times 1 plus sine theta. And I can express this as the difference of 2 squares in sine. Right? So cos, I can first write it as 1 minus sine squared theta over cos theta times 1 plus sine theta. And then this is now the difference of 2 squares, which is 1 minus sine theta times 1 plus sine theta divided by cos theta times 1 plus sine theta. And voila, this and that cancel each other, and you're left with this 1 minus sine theta over cos theta, which is the right hand side. So this is not one way to do them, guys. So you have 1 minus sine theta over cos theta. And that's the beauty about tricks. Usually there are multiple ways to do it, because you have all those trig identities you can use. That is the right hand side. And that finishes this question for trigonometry, and we are done with the revision of trigonometry. So the next topic we're gonna do vectors next after the break. Let's see. We're gonna do vectors after the break. I'm gonna take a 10 minutes break. All right, so this is now saying 1:15. I'm gonna start back at 1:25 in Jamaica, 2:25 in Trinidad. So let's take a break, guys. We'll be back in 10 minutes. All right, 2:25.
Yes, sir.
All right, take a break. I'm gonna start back with vectors right on this paper. Vectors right on this paper. Where is the vectors question on this? Right here. All right, so I want to do vectors, I want to do circular measures, I'm going to do coordinate geometry. Remember I said tonight, we're going to have a session tonight again, everybody, starting at 7 o'clock in Jamaica, 8 o'clock in Trinidad. After this session, we're going to take a 3-hour break, and then we're going to do another session tonight. We're going to look at logs, surds, indices, inequalities, and linear reduction to finish off module 1. So we'll clear module 1 and module 2, and then tomorrow now we'll start working on module 3, which is the differentiation and the integration, and some maybe we'll try to get kinematics as well. All right, so that is the plan. I know we have probability and statistics to do. So if we can have another session tomorrow, if we can reach one of those tomorrow, whether it be the probability and statistics, we want to reduce the amount of work that we have to do on Monday. All right, guys, break. All right, guys, ready again? Are you there? It's time for vectors. Everybody there? Hello?
Yes, sir.
All right, beautiful. I can tell you, vectors in ADMATS is easier than vectors in CSEC. Very, very easy. And as I go to the questions, there are a couple of things I might just explain. All right, but let me just do the questions as they appear. All right, so vectors at this level really is about how you go from point to point. All right, they might ask you about unit vector, which is a vector with a modulus of 1 unit. And the formula for unit vector is the vector divided by the modulus of the vector. And so you can transpose the modulus over here and see that a vector can be written as a product of the modulus and the unit vector. All vectors in the same direction have the same unit vector. All parallel vectors have the same unit vector. So if two vectors are parallel, the unit vector is the same for both of them. So if you can find one of the unit vectors, it's the same for the next. It's just like saying parallel lines have the same gradient. Vectors at this level also tend to speak a lot about perpendicular. When vectors are perpendicular, the scalar product is equal to 0. Scalar product. The formula for the angle between two vectors. First, the angle between two vectors is the angle between them when they are both diverging, and this is the angle between them, theta. When they are both diverging. So if this is vector A and this is vector B, then it is such that the cosine of that angle is equal to the scalar product divided by the modulus product, the modulus of A times the modulus of B. And how do we get the scalar product? We get the scalar product by basically multiplying and adding the components. So for example, if A is a vector, let's say, let's use some numbers. If A is a vector 3, 1, and B is a vector 4, -2, then using those, the scalar product A dot B is going to be 3 times the 5, which is 15, plus 1 times the -2, which is -2. The scalar product in this case will be 13. All right? Let's go get scalar product. We all know how to get the modulus. The modulus of A, this is A, it's going to be the square root of 3 squared plus 1 squared, because it's the length of the vector. And the modulus of B is going to be the square root of 5 squared and the 2 squared. I don't need to put the negative. I'm calculating the modulus. That's it. As I said, it's when they are both diverging, or it could be when they are both converging. So it could be that when they are both converging, like this, have to be both converging and both diverging. Right? Now suppose one vector is diverging and one is converging. Like for example, if one is going like so, but the other one is going like so. So one is going out this way, one is coming towards the point this way. The angle between two vectors is really the angle between their directions. Angle between their directions. So what I can do, I can extend this direction this way. And so this is the angle when they are both diverging. Or I could extend this one this way. And this is still the direction of that vector. And so this is the angle between them when they are both converging. If I extend back this one, you see that it is also this angle over here. So this will be the angle between them. All right. So the angle between two vectors, therefore, is also the angle between their directions. Angle between two vectors is the angle between their directions. All right. If two vectors are perpendicular, why is that so? Why is that? Why is it that scalar product is 0? So this is the formula for the angle between them. And so the scalar product, to transpose this formula, make scalar product the subject, and the scalar product A dot B will be equal to product of the modulus times the cos of theta. When they are perpendicular, the theta is equal to 90 degrees, and the cos of 90 degrees is equal to 0. Now, this is equal to 0 when they are perpendicular. It means that the A dot B is 0. So if vectors are perpendicular, the scalar product is 0. Now, what if they were parallel? Same formula, A dot B equals the modulus of A and the modulus of B cos theta. If the vectors are parallel, then the angle between them is 0, and the cos of 0 is equal to 1. So this will become a 1. So when they are parallel, scalar product A dot B is equal to product of the modulus A dot B equals scalar product. Scalar product equal modulus product. But then we dealt with parallel vectors from CSEC these. And if they are parallel, then one of them will be a constant and the next one. So we can go back to this theorem if they are parallel. The product of the one is a multiple of the next if they are parallel. All right, and that's a simple, quick revision of it. And now we can just run some questions. All right, it is not anything more than that, really and truly. Just remember, it's about how you go from point to point. You can review it that way. How do you go from point to point around a diagram, going along vector direction? This question gives us these two vectors, OA and OB, and it's telling us that AB is half of OA. AP is half of OA. All right, and they want us to find the vector BP in terms of the A and B. So they're telling us that OA is small a and OB is small b, and AP is half of OA, half of the vector OA, which makes AP half of A, because OA is A, small a up here. And I want us to find BP, vector BP. But to find BP, I can look at it and say, okay, BP is, I can go from B to P by going from B to A, and then A to P, since I have AP. Find the vector BP. Multiple ways to do it. I can go B to A, and then go A to P. How do I go from B to A? I can go from B to A by going B to O, and then O to A. And then I can go A to P. So this would be the AB right here. But put another way, this BA, I can use the displacement vector formula, which B to A is OA minus OB. O times the last minus O times the first. Why am I doing that? Because I have these. So it's better to write this as OA minus OB. So this is that. And then this AP, sorry. And then this AP is what was given here. So I can put in the values now. Nice and easy. The OA is A. The OB is B. So I'm subtracting B. And the AP is half of A right there. Plus half of A. So I have 1.5 A minus B. 1.5 is 3/2. So it's 3/2 A minus B. That's not the only way to do it, but that's a good enough way to do it. Then I want us to tell them the modulus of B. And basically, because we know the values of A and B here, we can drop them in this to get the values to get the modulus. So based on that, the BP initially will be 3/2 times the A vector. The A vector is 2, 1, minus the B vector, which is 3, 2. 3, 2. It's like 1.5. 1.5 times this 2 is going to give me 3. 1.5 times 1 is 1.5. I'm just going to write 1.5. Minus 3, 2. When I work out the vector, 3 minus 3 gives me 0. And then 1.5 minus 2 give me negative half, negative 0.5. So the length of this vector is just 0.5, because to go from B to P, it means that I'm just going down 5 units. 0.5 is like that. To go from B to P, it means that I'm just going down 0.5 units. That's what this means. And so the modulus is 0.5. By just looking, the modulus is 0.5. So the modulus of BP by observation is just 0.5 units. If you want to calculate it using the modulus formula, then BP, modulus of BP, will be the square root of the 0 squared and 0.5 squared. 0 squared plus 0.5 squared. It's going to come back to 0.5 units anyway. This question is very easy. So I think in CSEC they're trying to make up some questions. Then add something. Very easy. All right, that's the 2012 thing. Question. Very easy. Let's go to 2013. Working our way up. All right. I really want to get to the more recent questions. All right. These older questions, I don't think they're setting them like this anymore. They don't want to use scalar product and so on. So we're going up to 2013 now. So it is here. Let's see what I set on 2013 for the vectors. All right, which is right here. They're very easy, very easy, very easy, easier than CSEC. And this question says, the position vector of P and Q relative to an origin O are this one and this one. I'm going to write them like this, position vectors. So the position vector of P is OP. They give me this as 10, negative 8. I'm going to write as a column vector. 10, negative 8. It's the same thing. 10, negative 8. I'm just writing it as a column vector. I don't want to see the I and the J all over the place. It's just easier to see the values when I write it like that. And the OQ is this one. The OQ is that one. So the OQ is lambda 10. Lambda 10. It says lambda is a constant. It says find the value of lambda if they are perpendicular. Easy. If they are perpendicular, the scalar product is 0. OP is perpendicular to OQ. Therefore, OP dot OQ is equal to 0. So when you calculate the scalar product, it will be equal to 0. That's what we're solving. What's the scalar product? It is the 10, negative 8 dot the lambda 10 is equal to 0. So this time this is 10 lambda. So 10 lambda, and this time this is negative 80 minus 80 is equal to 0. So clearly the lambda equals 8. Lambda equals 8. Care about the 10, care about 80, get 80 divided by the 10, the lambda equals 8. Done. Right? 3 marks to do that. So this thing is super easy. Let's go to the next one. Lambda equals 8. This one says position vector of A and B, respect to origin fixed point O are these and these. I'm going to write them the same way again. So here OA is equal to minus 2, 5, and OB is equal to 3, negative 7. Question says find the unit vector in the direction of AB. So to find a unit vector in the direction of AB, we need to find AB first. Find AB first and then find a unit vector of AB. So firstly, AB is O times the last OB minus O times the first OA. O times the last minus O times the first. So basically doing this one minus this one, subtracting them. I would have to write them again. It's 3 minus a negative 2 becomes 5. 3 minus a negative 2 give me 5. Negative 7 minus 5 give me negative 12. That's a 5, 12, 13 vector, you know. So the length of that vector is 13, you know. You can look at it and see it. One was 13. Because if I were to sketch the vector, this means 5 to the right, 12 down. You go from A to B. That's what it means, you know. So here's 5, here's 12. It becomes a Pythagorean triple, 5, 12, 13. So right here, so it's 13. So I know the length of this vector is 13. I don't have to work it out. Right? So the unit vector AB, just looking at it, would be equal to 1 over 13 times the vector itself. Okay, divide the vector by the modulus, 1 over 13. But if you don't know that, we can calculate it. Let's say we couldn't observe this. Then we could calculate it. Because the unit vector of AB, which is written with a hat on it, this means unit vector, is equal to 1 over the modulus of AB multiplied by AB itself. What's the modulus of AB? It is the square root of 5 squared and 13 squared and 12 squared, sorry, 5 squared and 12 squared, 5 squared and 12 squared. And then multiply by the vector itself, which is 5 negative 12. This one here is a 13. That becomes 13. That's 25 and 144. That's 169. Square of 169 is 13. So it becomes 1 over 13 into 5 negative 12. So dividing each of them by the 30. Because they give me a question with the I and G, I'm going to give them by the final answer with the I and G. So it's 5 over 13I. 5 over 13I minus 12 over 13G. 12 over 13G. So it's very easy. That is, vectors at this level is easier than CSEC. Believe me, much, much easier. Right, that's 2030. We're gonna finish this vectors part quickly, you know. Take another short break and then with the circular measures. All right, that's what we're gonna do. Let's go to 2014. 2014. The question just cannot be difficult. It cannot be difficult. The vectors question at this level cannot be difficult. It's impossible for them to be difficult because they're just not able to make them difficult. They're just too easy. So the vectors is up here, right here. Let's look at this one. This question says, RST is a triangle in the coordinate plane. Portion vector of RST relative to an origin ORDs. So remember, if you know the portion vectors, like you also know the points. So these are the coordinates. So 1 point is at 1, 1. 1 is 3, negative 1, and 1 is 4, 4. You can literally sketch it, right? So what we have are the vectors OR is 1, 1. OS is 3 minus 1. And let's put this a little closer. Let's bring this over someone. I'm doing this over someone. Let me write in too large. And then OT is the vector 4, 4. That's what it gave us. It says show that angle RTS is 90 degrees. Once it's angle, we're going to show that the vectors are scalar property is equal to 0. What are the vectors we're going to use? It's RTS, T is the point in the middle. So I have to decide. We're going to use R as a point in the middle, T up here, S down here. So we're going to use two divergent vectors, RT and RS. RT and RS. So we need to find RT and RS. And then if the angle is 90 degrees inside here, then the scalar property is 0 between RT and RS. So RT is OT minus OR. Notice that I put the R on top of them all the time because I'm talking about vectors, which is equal to, I'm doing this one minus this one. OT minus OR. So it's 4 minus 1 is 3, and 4 minus 1 again is 3. So that is RT. And then RS now is OS minus OR. So I'm doing this one minus this one now. So that becomes 3 minus 1 is 2. And minus 1 is negative 2. Those are two vectors. If I scalar product them to get the angle between them, RT No, to see the relationship, to see what the scalar product is. RT dot RS, because if we're going to show that they have 90 degrees, we can do that by showing that the scalar product is 0. RT dot RS becomes this value times this value, the product of those two values. It's like you're doing this 33 dot 2 minus 2. So the product of these two is 6. The product of these two is negative 6. That is equal to 0. Therefore, the angle between them is 90, and so the angle between them is same. See here, the same angle right here. TRS on that sketch. So you can say therefore angle TRS, which is the angle between them, is equal to 90 degrees. But the scalar product of the vectors from out there is 0. It says determine the length of the hypotenuse. So look at this diagram now. So this angle is 90. Let me draw it properly then. Let me draw it like a 90. So this is a T up here. And we use RT. We want the length of the hypotenuse. So this becomes the hypotenuse. Right? This becomes the hypotenuse. Put a different color. This is the hypotenuse right here. We want the length of it. So we can do that two ways. We can find the vector TS and find the modulus of TS. The hypotenuse is TS. So we want the length of the hypotenuse, we need the length of TS. That's what I want to tell them first. The hypotenuse is the vector TS, where TS is OS minus OT. O times the last minus O times the first. OS minus OT. OS, remember now, is this one minus this one, right? So it's 3 minus 1 minus 4, 4. Let's write them out. Could have gone the other way too. Could have gone TS or ST, doesn't matter. So we're doing this minus this right now. So it's 3 minus 1, 3 minus 1 minus 4, 4. That is the vector TS. It becomes 3 minus 4 is negative 1, minus 1 and minus 4 is negative 5. Now the modulus of it, so the length of it is the modulus of TS, which becomes the square root of 1 squared and 5 squared. That becomes the square root of 26 units. Done. That's it. Hear them say, draw a rough diagram. Right? Draw a rough diagram. So you see, I didn't even say that they tell them to draw a rough diagram. So I did. Sometimes you draw a diagram to see what you're playing or what you're working. That finishes that question. Everybody good? Everybody okay?
Yes, sir.
All right. The more recent ones will be different, right? I can tell you that. The more recent ones will be different. That's when I start getting different. All right. We're doing 2015 now, which is right here. That's when I start getting different. All right. Let's see. Here. So we're going back to get the vectors. All right. Let's look at this. That part B is the vectors. I'm going to finish this part of it quickly. The questions are very short. It says the portion vector of A and B are these. So I'm going to write them out. OA is a vector 3 minus 2, and OB is a vector 5 negative 7. I'm going to write them as column vector. Determine the unit vector AB. The unit vector AB. So again, to find the unit vector of AB, we find AB first and then calculate the unit vector. So we're going to calculate AB first. So AB is OB minus OA. O times the last minus O times the first. Last minus first. So the vector is AB, then B is the last and A is the first. So it's O times the last minus O times the first. So basically doing this one minus this one. So we can just work it out right here. 5 minus 3. 5 minus 3 is 2. Negative 7 minus a negative 2. Negative 7 minus a negative 2 becomes minus 7 plus 2, which is negative 5. That is the vector AB. And we're going to write the unit vector of AB is 1 over 1 times A. That's all they're doing. That's how we get the unit vector. So it becomes 1 over the modulus, which is the square root of the 2 squared and the 5 squared. 2 squared and the 5 squared times the vector itself, which is 2 negative 5. Gotta give me the question in I and J. I'm gonna give them about unit vector in I and J, but I'm just working it out first. This under here becomes root 29. So it becomes this over root 29 and this over root 29. So it finally becomes 2 over root 29 I minus 5 over root 29 J 29 J. That's my unit vector. Then to find the acute angle in degrees to 1 decimal place. So which two vectors am I using? Remember, I've used 2 divergent vectors or 2 convergent vectors. So this is over 1 angle at O now. I have to use O to A and O to B. So I'm using OA and OB. And the angle I'm using is theta. I want to calculate theta, the angle between them. And I want it acute. So if you work it out and get it obtuse, you subtract from 1 to get it acute. So I'm using the vector OA and the vector OB. Both of them divergent from O. Let's go now. So I'm calling the angle theta. So the angle theta is going to be cos to the minus 1 of the scalar product OA dot OB over the modulus product. Modulus of A times the modulus of B. So I have to work those out. All right? Let's write by the vectors again, right here, so that they're in front of us. So OA was the vector from here, 3 minus 2, and OB was the vector from here, 5 negative 7. So theta equals cos to the minus 1 of the scalar product first is this times this minus, no, plus this times this. This time this is 15 plus this times this is positive 14 divided by the modulus of this one first is the square root of 3 squared and 2 squared times the square root of this one now is 5 squared plus 7 squared. And you can just put all of that in the calculator. Theta equals cos to the minus 1. This up here becomes 29 over, this is 9 and 4. 9 and 4 is root 13 times root, this is 25 and 49. 49 and 25 is how much? 49 and 25.
74.
How much? 74.
74.
74. Well, let me take this. I'll take this. Hello? Sir Mark. Yes, Sir Mark. What's up? Sir Mark, let me call about later on it now. Can I like a meeting? Let me call you back on it. Yeah, cool. All right, sorry about that, guys. All right, so let's work this out to the calculator now for me, please. I'm going to give the answer to 1 decimal place. 1 decimal place, and we're done. Anybody can tell me? Nobody's working this out for me. I have to do everything for myself.
20.8.
How much?
20.8.
20.8 degrees. That's the angle between them, and it's acute. All right, that's it. Done. 2016. Let's go. 2016. 2016. 2016. 2016. Right here. We're doing all of the vectors questions. Right here. Let's see if any of them pose a challenge. Let's see, I doubt it. Right here, this is a vectors question in this paper. 2016. All very easy stuff, easier than CSEC. This question says the position vector of A and B relative to origin O are small a and small b. Right? And here, small a and small b. Small a is this one, small b is that one. So essentially, OA is a vector 1, 2, and OB is a vector negative 3, 5. And they tell us that P lies on AB such that PB is a quarter of AB. Let's write that out. PB is a quarter of AB. So because we have the position vector of these two, we can actually find this one, because that is just OB minus OA. Question wants us to find the position vector of OP. It wants us to find OP. Multiple ways this can be done. I can take this vector equation and I can split it up into position vectors and work towards finding the OP. And do that, you know, right? To get the OP. Right? So I'm going to use this equation. I'm going to split it up into position vectors. That's what we're going to do. I'm going to split this side into OB minus OP. That's what this side becomes. Equals a quarter AB. And AB is OB minus OA. I just need to make this a subject now. I'm done. What do I make that a subject? I can take this and bring it over this side and make it positive. Take all of this and bring it over this side and make it negative. I'm going to get OP over here equals OB minus a quarter into OB minus OA. Done. Let's chop in the values now. So OP is equal to OB first. OB is negative 3.5 minus a quarter into, I'm doing OB minus OA now. OB minus OA. Let's look at it. OB minus OA. I'm putting it inside here. So it is negative 3 minus 1, that's negative 4. And this is 5 minus 2 is 3. That's what I'm working on right there for OP. So it's minus 3.5. And then it's minus a quarter times, I can just put the minus right here and work just the value on that, right? So it becomes a quarter of negative 4 is negative 1. A quarter of 3 is 3/4 or 0.75. That is OP. And when I consolidate minus 1 minus a plus, I get negative 2 up there. And 5 minus 3/4 is 4 1/4, which is 4.25. And that is my OP. And that's it. Done. What about the coordinates of OP? Well, when I say coordinates, you really can say P is a point, negative 2, 4.25. If you want coordinates of the point. But I'm saying I really want this vector. So this is the this is the answer right here. That's my answer right here. This is OP. That's my answer. Easy like that. So I take this vector equation that they gave me, and to extract the OP out of this, I split it into O times the last minus O times the first, and then I transpose to make this a subject over there. And then I just work out everything else, and that's it. Very easy stuff. It's not complicated. Question done. 4 marks for doing that. That's not the only way to do it, but that's an easy enough way to do it. All right, 2017. 2017 next. 2017. So when you have a vector equation, you want to get a position vector out of it, you can split it up into position vectors. O times the last minus O times the first. Split up into position vectors. I'm looking for 2017 next. 2017. Right here. 2017. All right, so we'll start work on the paper now. 2017. The vectors question. Where are you? Right here. It's number 3. All right, let's look. 2017 vector right here. It says, given this vector, that vector, find the product of them, scalar product. I'm going to write like that. P is the vector 2, 3, and Q is the vector 1, 5. So you can see the values. They want the product. They're talking about the scalar product. That's P dot Q equals product of these two, which is 2, and the product of these two, which is 15. So scalar product is 17. Easy stuff. The angle between them. The angle between them is the cos to the minus 1. Theta is cos to the minus 1 of the scalar product P dot Q over the modulus product, the modulus of P and the modulus of Q. That gives us the angle between them. We already know that this is 17. We need the modulus of them under here now. Right, let's make this smaller and get some space. Alright, so it becomes equal to cos to the minus 1 of 17 on the modulus of P is the modulus of this one, which is the square root of 2 squared and 3 squared, times modulus of this one, which is the square root of 1 squared plus 5 squared. And if you put all of that in the calculator, you get the answer. It's an easy. All right, it becomes equal to. You can just write the answer for this now. Just put everything in the calculator. Kai, put that in the calculator for me. Quickly. Let's put it in the calculator. So it becomes cos to the minus 1 of a fraction 17 over this under here, so is 9 plus 4 is 13. Let's check it. 13 times, and then this now would be 25 and 1 is 26. It becomes 26. And it's 22.4 degrees. That's what they got? Good. 22.4 degrees. Question done. Very easy number. Next question, 2017, 2018 next. Easier than CSEC by far, by a mile. They are a mile easier than CSEC. 2018 next. Where are you? 2018, right here. What's happening here? The 18 vectors. 18 vectors. 18 right here. This is another one up there. No. 2018 vector says portion vector of A and B vector origin O are this one, and this one. Find the magnitude of AB. So they give me OA is 2, 1. OB is 3 minus 5. We want the magnitude of AB, so I need to find AB first. AB is OB minus OA, which works out to be this one minus this one. So it's 3 minus 2 is 1. Negative 5 minus 1 is negative 6. That's AB now. The magnitude of AB now is the square root of 1 squared plus 6 squared. 1 squared plus 6 squared. This is 36 and this is 1. So it becomes the square root of 27 units. Magnitude is the length. So I put unit. Done. Easy. 2 marks for doing that in an exam paper. I can believe that. 2 marks for just doing that. Next part was the angle AOB giving the answer to the nearest whole number, the angle. The angle is when they are both diverging from O as I said. So divergent to A, divergent to B, the angle is between them here. They're going to use the vector OA and the vector OB. Always double check that. So the angle between them we call the theta. So theta is cos to the minus 1 of the scalar product over the modulus product. So it's OA dot OB over the modulus of OA times the modulus of OB. That's what they're working on. Equals. That's the OA and that's the OB. All right, the scalar product first. So it's cos to the minus 1 of this 2 times this 3 is 6. This 1 times this negative 5 is negative 5 over product of the modulus. We can put it under here. All right, I'm writing them out here. OA is 2, 1. OB is 3 minus 5. All right, so the modulus of this one, which becomes the square root of 2 squared and 1 squared. Let me shift this down here. So running out of space. Put it under here. And the modulus of this one is the square root of 3 squared and 5 squared. Put that in the calculator and work it out. And put it up here on this calculator. That becomes 6 minus 1 is 6 minus 5 is 1 over this under here so becomes 5. So it's the square root of 5. And this under here says 25 and 9. 25 and 9 is how much? 34? 34. This times 34. That becomes 85.6 degrees. Nobody have any business getting a vector question wrong on the examiner. They're too easy. They are too easy to get wrong. They make any sense to get them wrong. It's too easy. They're not testing anything. That's 2018. Let's look at 2019 now. 2019. 2019. Vectors must be the easiest topic on the paper. 2019 is right here. 2019. Let's go. Vectors over here. All right, see it now. This is B. Vectors gonna be. Look at that. Easy stuff. Question says they give us these 2 vectors. So if I write them as column vectors, P is H2 and Q is 1, negative 4. They want us to find a scalar product. So P dot Q equals the product of these 2, this times this, which is 8. And 2 times this is negative 8. They equal 0. It means that they're perpendicular. Stay down between them, 90 degrees. They are perpendicular. The scalar product is 0. They are 90 degrees apart. Scalar product is 0, so they are 90 degrees apart. Easy. Simple as that. Next part says, position vector of A is that. Find the unit vector AB. So the unit vector A hat is 1 over the modulus of A times A itself. That's what we're working on. So it becomes 1 over the modulus is the square root of 4 squared plus 7 squared. 4 squared plus 7 squared, multiplied by the vector itself, which is 4I minus 7J. What is work out on here? That's, I'm not going to work out the actual value now. It's 16 plus 49. That's 65. So it becomes root 65. So it becomes 4 over root 65 I minus 7 over root 65 G. And that's it. Done. Right. Done. All right. 2021. Let's go. I finish this vector, take a short break, right? 2021. 2021. Because there was no exam in 2020. 2021. 2021. 2021. So we have 2 more papers to do after this. They're very easy. So we run through this topic quite quickly. And the vectors question is just this right here. Just this. This says a position vector of P and Q, relative to an origin O. And this one and that one, P and Q. Determine unit vector direction PQ, given an answer in simplest form. The same thing I keep asking. So one unit vector of PQ, we need to find PQ first. So PQ is OQ minus OP. O time the last minus O time the first. So it's this one minus this one. So it becomes equal to -4 minus 2 is -6. And 1 minus a -3 becomes 1 plus 3, which is 4. That's the vector. So the unit vector, which is PQ with the hat, is 1 over the modulus of PQ times PQ itself. That's how we get the modulus. That's how we get the unit vector. So it's 1 over the modulus, which is the square root of the 6 squared and the 4 squared, times the vector itself, -6, 4. What is the work out to? This is 36 and this is 16. Let's work it out. 36 and 16, that's 52. So it becomes equal to -6 over root 52 and 4 over root 52. That becomes the answer. Done. Finito. Good. Finishes that question. Tell you the easiest question on the paper in the vectors. 2022 next. 2022. Must get the vectors question right in the examiner. Must. That's so easy. 2022 next. Where is it? 2022 right here. I'm gonna do specimen and then that's it. Take a break. Take a short break and come back. I'm gonna do quadrant geometry with circles. All right, so vectors up here. See here, this is our ask for vectors. This is all right here. This is it. 2022. OX and OY are these. OX and OY are these. So OX as a column vector is 4, 1, and OY as a column vector is 1, -4. Is going to be perpendicular. Show that they are perpendicular. The perpendicular scalar product is 0. So OX dot OY is equal to 4, 1 dot 1, -4. They become 4 times 1 is 4. And 4 times -1 is -4. So equals 0. And since the scalar product is 0, it means that they are perpendicular. OX is perpendicular to OY because the scalar product is 0. That's all you have to do. Show that the scalar product is 0. It's 5 marks to that, guy. 5 marks, show that they are perpendicular. Once the scalar product is 0, they are perpendicular. So that the easiest marks to get in the exam are the vectors questions. They're 100 times easier than CSEC. Let's go to specimen paper and see what if there's anything nice on it. That is really ridiculous easy. Let's see. Right here. No. Where is it? Where is it? This thing right here. Let's look for the vectors question on it. Let's look for it. Right here. It's the same thing again, really. Easy stuff. It says, what's the vector of 2 points A and B where to origin O are these? And that. It said the point P lies on it such that OP is equal to PA. So determine the vector BP. The same question, you know. OP equals PA, we can put on these because they are on the line OP, right? P is on the line OA, and P is right here. OP is equal to PA. So it means that P really is a midpoint, right? It means that P is a midpoint, you know. That's what this means. P is a midpoint right inside here. Right? And I want us to find BP. BP. Multiple ways to do this. If you want to find BP, let's say B is right here. And you want to find BP. We can go B to O and then O to P. And we can do that in this diagram. We can go B to O and then O to P. And that is what the BP is. B to O and then O to P. Right? But we can also just use position vectors like this. We want to find BP because they gave us OP in it. We know OP. They tell us that it is PA. Alright? So we can say the BP that we want is OP minus OB. That's O on the last minus O on the first. The OP is PA. Oh, we need to do some work. We need to do some work. We need to do some work. We need to do some work to find the OP properly. All right, let's look at the diagram. Can you turn the diagrams to, you know? I'm trying to just show that it's easy. All right. We're gonna split up this first to find out what the OP is proper. I'm gonna split that up first to find out what the OP is. You can see it on the diagram too, you know. Look, let's look at the diagram again. So it's like you have OP is on OA. So this is OA. All right, let me set it up this way. So it's like you have 2 points A and B, and O is right here, and you have the line O. Now A, and this is point P. So based on that, OP is just half of OA now. Right? P is on OA such that P is equal to PA. So right there, so OP is half of OA, just like that. So the OP is half of OA. So it becomes half of OA minus OB. That's what it becomes, guys. Simple as that. Not gonna complicate it. So it's half of this becomes negative 2/3 minus OB, which is that, minus 3 minus 4. So we get 2 minus is a plus. So that's like 3 minus 2, which is 1. And then this minus is a plus, gives us 7. That is a vector BP. Just too easy. That finishes this little segment, guys. You see that the vectors really is nothing. They're nothing question on the paper. It's really a nothing question. All right? What time is it? It's now 3:20. How long break do you want to take? Take another 10 minutes break. How long break you want to take, guys? We'll come back to the next. The next topic we're doing is the coordinate geometry with the circles. Those questions are a little bit more lengthy. All right, and then we can that will take us to the end of the session. That will take us to the end of the session. Coordinate geometry question. Right? All right, want to take a 20 minutes break? Hello?
Yes, sir. Thank you.
All right, so it's now 3 o'clock, 3:20. Come back at 3:40. Come back at 3:40.
Okay, sir.
All right, 3:40.
Wow. Yeah, no, man, pretty good. Então, morando em Venezuela.
All right, guys, ready again? Are you there?
Yes, sir.
Yes, sir.
All right, beautiful.
Yes, sir.
All right, so we're gonna run through. We have about an hour to finish this session. Remember, we're starting back at 9 o'clock. We want to do the SIRS, logs, and we're starting back at 8 o'clock, Tobago time, 7 o'clock, Jamaica time. That's 3 hours after we finish. We want to do SIRS, logs, indices, and inequalities, and linear reduction. And then we'll break until tomorrow. I want to cover all the topics in them. All right, so now I'm going to do the questions with circles. All right, I'm going to do all the questions with circles. There are multiple ways to do these questions, but the method that I use is the one where I go for the standard form of the equation of a circle, which is x minus a squared plus y minus b squared equals the radius squared. AB is the center of the circle. And R is the radius of the circle. That's the method I tend to approach. I'm always looking to get this format. So when they give it to me in this standard form, this is the expanded form or the general form. I tend to want to complete the square of the term to get it in this form. All right. I know there are other ways of reading the center from here, formula method, reading the center and the radius from this format, but I don't get into that formula method. All right. I tend to just expand it out, complete the square and get it into the standard form and work from there. All right. So that's the approach I'm going to be using. So if you have another method to do it, you can use the other method to do it, no problem. All right. Another thing I want us to recognize is that when we deal with equations of circles and you want to find the equation of a tangent, the normal, I usually say the normal is your best friend. This normal guy right here is your best friend. It helps you to find the tangent because it is perpendicular to the tangent. And the beauty about it is that you know that it passes through the center. The normal will always pass through the center point. And so it's normally easier for you to find the gradient of that normal. And once you know the gradient of the normal, the gradient of the tangent is the negative reciprocal of the gradient of the normal. All right? So the normal is your friend when you're dealing with these questions. We're doing differentiation of curves, dy by dx and so on curves. And in that case, the tangent is your friend because the tangent, the gradient of a tangent and the gradient of a curve is the same. All right? So when it comes to equations and so on, the tangent is your friend. When it comes to equation of a circle, the normal is your friend. The normal helps to find the tangent. In case of curves, the tangent helps you to find the normal. All right? Okay. All right, so let's do these questions now. Let's go. So I'm going to start this as a specimen paper, working our way all the way down to 2012. All right, let's see if we can finish that in this short time. Let's go. All right. So this question says, a circle has this point at its center. So know that this is our AB, for the center point. And a point P is on a circumference. So this point is on a circumference. It means that the distance between these 2 points from the center to the circumference is the radius. In the center and the circumference is your radius. Any distance from the center to the circumference is radius. It says you have to determine the equation of a circle and express it in this form. So because they already gave me the center, all I need to calculate now is the radius. Because I'm going to put it in this form, and I'm going to put the equation in the form x minus a squared plus y minus b squared equals the radius squared. I already have the a and the b from this. All right? And so all I need is the radius. So my radius r will be equal to the length CP, which is equal to the square root. Difference in the x value squared plus the difference in the y value squared. So it's this 5 minus this negative 3, it becomes 5 plus 3 squared plus difference in the y value squared. This 2 minus this negative 4 squared. That becomes 2 plus 4 squared. Remember, the length of a line is the square root of x1 minus x2 squared plus y2, it doesn't matter the difference, y2 minus y1, y2 minus y1 squared. That is it. So the difference in the two x values squared plus the difference in the two y values squared. That's how we get the length of a line, and that's the formula that I'm using. So that these are negative, and so when you subtract them, they become a positive. This works out to be, this is 8 squared is 64, and this is 6 squared is 36, right? 36. That's square root of 100, which is 10, right? Square root of 100, which is 10. So the radius is 10. And so the equation of that circle is, using this format, is x minus this x value, which becomes a plus 3 squared, plus y minus this y value, which becomes a plus 4 squared, equals the radius squared, 10 squared. That's the equation. I have to expand it out in this now. That's what they said I wanted. When I expand this, it becomes x squared plus 6x plus 9. When I expand this, I get y squared plus 8x plus 16, not x, y right here. And then this 100 come on this side, and so I'm subtracting 100 equals 0. Then we consolidate and we're getting into that format. So it's x squared plus y squared. That's this one and this one. And this is the only x value there. So it's plus 6x. This is the only y value there. So it's plus 8y. And then I'm consolidating this and that. So these two is 25. 25 minus 100 is negative 75. So minus 75 equals 0. So that is my answer right here. Gotta go to that?
Yes, sir.
Okay? All right.
Yes, sir.
Beautiful. Next part says determine the equation of a tangent at this point. So I'm gonna sketch it. I'm gonna look at a sketch so we can see what is what. Remember, we want to find the normal helps you to find the normal helps to find the tangent. Keep your mics muted for me, please. Keep your mics muted unless you're saying something. All right. So I'm gonna make a sketch just to show what we're doing. All right, and the sketch is not an accurate sketch, it's not an actual sketch, right? Just a schematic of what they have said. So we have the center point, which is -3, -5, from -3 is -4 from here. -3, -4. And we're talking about the tangent at that point P. I'm going to draw the tangent in blue. So like I'm trying to find this tangent line. Let's put T for tangent. But the normal is going to help me. I always need the normal to help me, because the normal passes through both points. That's my normal. And this point is 5, 2, the P point. So because it passes through both points, I can find the gradient of it. The normal and the tangent are perpendicular. All right? So the tangent passes through that point already. So we know the point and the tangent. But what we need now is a gradient of the tangent. So we're going to calculate the gradient of the normal first. So gradient of the normal, this means gradient of the normal is equal to the difference in y over difference in x between those 2 points, because it rise over run. So it's this y value minus this y value. So it's 2 minus a -4 over 5 minus a -3. 5 minus a -3. This up here is a plus, so it becomes 6. This is a plus again, it becomes a 8. that reduces to 3/4. So the gradient of a tangent, let me write it in blue now that we really want. The gradient of a tangent is -1 over the gradient of a normal. This calculation can be done quickly by flipping this one and changing the sign. That's how we do the negative reciprocal. Flip the one that we have and change the sign, it becomes -4/3. I'm using this -4/3 gradient with this point, because that's a point on the tangent as well. The equation becomes y minus yp equals the gradient of a tangent into x minus xp. That's how we can get the equation of a tangent. And so it's y minus the y value at the point of tangent is 2. The gradient is -4/3 into x minus the x value at the point of tangent is 5. All right, so that's how we're gonna get it. Let me shift this up a bit. Get some more space. I'm gonna shift this over to here. All right. So to simplify this, I'm going to multiply this 3 across to this side, and I'm going to multiply this -4 inside the bracket here to simplify. So it's a 3 times the values over here gives me 3y minus 6. -4 times the values in here gives me -4x plus 20. -4 times -5 is +20. Because it's transpose this 6 now. And I'm going to get 3y equals -4x plus 26. That's the equation of my tangent. This is my answer right here. The equation of that blue tangent. What about that? Right, okay?
Yes, sir.
Yes, sir.
Yes, sir.
And that's the extent of the questions most times. All right, so let's look at 2020 now. Let's look at 2020. There's another question that you all need to make sure you get right, but they don't vary how they set this question a lot. So 2020. All right, I'm looking for the coordinate geometry, which is right here. Right there. Question says, so give us the equation of a circle as this. They want us to determine the center, the length of the radius. Right? And I can look at it and see the coordinates of a center. But I prefer to, and I can also calculate the length of the radius, but I prefer to rewrite this in the standard form by computing the square. So I'm going to compute the square of these x values first, and I'm going to get x, and then half of the 2, which is half of the 4, which is 2 squared, and then minus the square of this, which is 4. And then I'm going to compute the square on the y values. So it's going to be y half of this is -4 squared minus the square of this is 16. So I've taken care of these 2 values and of these 2 values. And I now need to introduce back this -10 equals 0. Better go to that. Better go to that.
Yes, sir.
All right. And so it becomes, let me change the color. And so it becomes x plus 2 squared plus y minus 4 squared. I'm consolidating these values now. So this is -26, that's -30. Goes over on the right side and becomes a +30. And 30 can be written as the square root of 30 squared. So I'm getting it in the form x minus a squared plus y minus b squared equals the radius squared. So if we look at the values, this is a +2, but I really need a minus a. So the a is actually -2. So my center point is -2 4, because this is a -4 and it's a minus b. So the b is a coordinate at the center, so the b is 4. But the a right here will be -2, right? Because I have negative a equals positive 2, so the a is -2. That's my center point, and my radius r becomes the square root of 30. What about that?
Yes, sir.
Next part says determine equation of a tangent at this point. So it's the same thing again. Normally I like to make a sketch so I can have a look at it. The center point is -2, 4. I'm going to put my tangent line in red. This is a point of tangency. The normal is my best friend. Let's put it in purple. It passes through the point of tangency and also passes through the center, my normal point, my normal. And the point it gave us is the point right here, -5, -5, 5, 5, sorry, is a point of tangency P. And I'm trying to find this tangent. I'm going to get the equation of the normal first. The gradient of the normal, sorry. So the gradient of the normal, the difference in y by difference in x. So it's 5 minus 4, 5 minus 4 over -5 minus a -2. That becomes -5 plus 2, because minus minus are plus. This becomes 1 over -3. That's going to have a normal, and we can therefore write the gradient of a tangent. Therefore, the gradient of a tangent is the negative reciprocal of that. So it becomes a 3. Flip this and change the sign, that becomes the gradient of a tangent. So using this tangent gradient and this point to find the equation of a tangent now. So the tangent becomes y minus the y value at the point equals the gradient of a tangent into x minus the x value at the point. So it's y minus the y value at the point is a 5 equals the gradient is 3 of the tangent. X minus x value at the point is a -5, so it becomes x plus 5 because minus a -5, x plus 5. There are no fractions here to do, so expand this straight. So y minus 5 becomes 3x plus 15. This 5 goes and add to that. So y equals 3x plus 20. That is the tangent equation. That finishes that question. Anything else? I'm going to geometry? No. That finishes that question. But okay, I like to do the sketch so we can visualize. I like to do that sketch when they ask for the equation of a tangent in particular. But good?
Yes, sir.
All right, let's go. 2021. 2021. Let's work them down and see if there's anything different on any of them. Right? 2021. 2021. So they're asking for the tangent again in this question. So you see, that's why I can't understand how people fail this exam, because they basically ask the same thing every year. Right? They ask the same thing every year, just different values. So no reason to fail this exam. It says the coordinates of a center point is this. So they give us a center point. The coordinates of a point and the circumference is this. Just like the question we did a while ago. So the radius is the length between here and here. That's the radius. The distance between those 2 points is the radius. And this is a center point. All right? So I want to do the same thing. I want to get the equation in this form. Get it in the standard form and then expand it out into what we call the general form. This is a general form. Get it in the standard form first. So we need a radius. So the radius is the distance between these 2 points, which is the square root of the difference in the x value squared. So it's 3 minus 2 squared plus the difference in the y value squared, 3 minus 1 squared. This becomes, this is 1 and that is 2. So that is 1 squared and 2 squared, that's 5. 1 and 1 is 5. The radius becomes the square root of 5. That's the radius, the square root of 5. All right? So it means that r squared is 5. And then the equation of a circle then, is x minus the x value at the center point, which is 2 squared, plus y minus the y value at the center point is 1 squared, equals the radius squared. And if you square this, or we can put it like this, the radius squared, and expand it out in the general form. This is a standard form. You have to expand it out in the general form. Expand this first. I get x squared minus 4x plus 4. Expand this, I get y squared minus 2y plus 1. This becomes a 5. 5 transpose over this side, give me negative 5 equals 0. So it's x squared plus y squared. That's this one and this one. This is the only x value in there, so it's minus 4x. That's the only y value in there, so that's minus 2y. This is 4 and 1 is 5. 5 minus 5 is 0. So the numbers are eliminated, and this is equal to 0. That is it. There's no c value there. All right. Then, as usual, let's say the circle intersect the x-axis. Says the circle intersect the x and y-axis at 3 points. At 3 points. X and y-axis at 3 points. Determine the coordinates of the 3 points. So we're gonna do them one at a time. So on the x-axis, we know that the y value is 0. So on the x-axis, this becomes a 0 and this becomes a 0. Because the y value is 0. And so what will happen is that the equation is going to become x squared minus 4x equals 0. If you factorize this, it becomes x minus 4 equals 0. So x is equal to 0 and x is equal to 4 on the x-axis. So the points are 0, 0, 0, 0, and 4, 0. 4, 0. So those are the 2 points on the x-axis. Then on the y-axis, the x is equal to 0 on the y-axis. And that is going to lead us, when the x is 0, this will be eliminated and this will be eliminated. Then we're left with y squared minus 2y. So the equation is going to become y squared minus 2y equals 0. This factorizes into y minus 2 equals 0. So I'm going to get y equals 0 and y equals 2. And so the 2 points here are going to be 0, 0 from this one and 0, 2 from this one. And so the 3 points, and write the answer here now in red. The answer, question is asking for the 3 points. Determine the coordinates of the 3 points. The 3 points are 0, 0 right here, 0, 0, 0, 2, and 4, 0. So these 3 points are my answer points, my answers. These 3 points at the intersect. Very good?
Yes, sir.
Good. All right. Then we continue down here. Determine the equation of a tangent at the point 3, 0. Same thing again. Why do it any different? I'm not going to do it. I'm going to sketch it again so I can see it. I'm going to put in my center point. What is the center point again? 2, 1. What is it? 2, 1 is a center point. So right here is 2, 1. I want the tangent at 3, 3. I'm going to show my tangent here in red. Put a T for tangent. I'm going to use my normal because a normal will always help. That's my normal line. The normal passes through both points. To do it about the normal, so it passes to the point 3, 3. And always get the gradient of the normal first. The normal is your best friend when you're doing circles, because it passes to the center. You know that. You can find the gradient of it. Easy to find it. Easy to find the normal. So the gradient of the normal, again, the difference in y over the difference in x between these 2 points. So it is 3 minus 1. That's the difference in the y values. 3 minus 1 over the difference in the x values. 3 minus 2. 3 minus 2. That becomes 2 over 1, which is 2. And if that's the gradient of the normal, then we can conclude that the gradient of a tangent, so we can say therefore the gradient of a tangent is minus 1 over the gradient of a normal, which is calculated by flipping this 2 and changing the sign. We get negative half. Or simply just drop it under here for the gradient of the normal. So we get negative half. And then the equation of that tangent now. The tangent I'm talking about now. The equation of the tangent, the red tangent, is y minus the y value at the point, which is 3, equals the gradient of the tangent, which is minus half, into x minus x value at the point of tangency, which is 3. I'm going to multiply this 2 across here by these 2 values, and I'm going to multiply this negative 1 inside the bracket here. So 2 times these values across here is going to give me 2y minus 6 equals negative 1 times the terms in this bracket is going to give me minus x plus 3. I'm going to transpose this 6 and add it to that 3 to give me 9. So I'm going to left with 2y equals minus x plus 9. And that is my equation right there. Done. See, they keep asking the same thing every year. Nobody have any reason to get questions like these wrong. Keep asking the same thing all the time. Let's go down and do 2019. More maths equals better maths. The more times you do it, the better. The more times you see it done, the better. More maths equals better maths every time. All right, so let's go for this one. See what they're asking. It's going to be the same thing again. So you see, I can't understand how people feel at maths. When they keep asking the same thing, determine the equation of a tangent at that point. They keep asking the same thing every year. Every year. A circle has a center point of that and passes through that point. Same thing. The radius is the distance between these 2 points again. Calculate the radius. This time I don't want to calculate the radius by itself. So the radius r is the length between these 2 points, which is square root, difference in the x value squared, 4 minus 1. 4 minus 1 squared plus 3 minus a negative 1. 3 minus a negative 1 becomes 3 plus 1 squared. Work this out. The radius equals the square root of 3 squared plus 4 squared. That's 5. The radius equals 5 and say units, because the radius is the length of that line. All right, that's the length of the radius. One know that's 5. That's a 3, 4, 5 triangle. This is 9 and 16 is 25. Square root of 25 is 5. That's a 3, 4, 5. 3, 4, 5 Pythagorean triple. So it's a 3, 4, 5 Pythagorean triple. So that is 5. All right. Then let's now write the equation of the circle in this form. I'm going to start by putting it in the standard form first. Center point AB for the circle is this. 1, negative 1. And now we drop it in the equation. X minus a squared plus y minus b squared equals the radius squared. Dropping the values in there. It says x minus the a is 1 squared plus y minus b, but b is negative 1, so it becomes a y plus 1 squared equals the radius is 5, so it's 5 squared. That's what we're working on. Let's expand it out to this now. X squared minus 2x plus 1, that's what we're going to expand that, plus y squared plus 2y plus 1. Transpose is 25 because I want 0. So it's going to be minus 25 equals 0. Consolidate. X squared plus y squared. That's this one and this one. This is the only x value. That's minus 2x. This is the only y value. That's plus 2y. The numbers. This and this is 2. 2 minus 25 is negative 23 equals 0. Done. That is the equation, sir. Right there. Nice and easy. It's practically the same thing. Determine the equation of a tangent at this point. I'm not going to do it any differently. I'm going to make my sketch. I'm going to put on my center point, which is 1, negative 1. I'm going to put on my point of tangency right here. Sketch it the same as our schematic. I'm going to show my normal line, my tangent line, sorry, and the normal is my best friend because it passes through both points and I can find a gradient of it. I'm always going to do the sketch. They are perpendicular, and the point of tangent this time is 4, 3. Again, the normal is my best friend. I'm going to find the gradient of it first. It helps me to find the gradient of the tangent. So the gradient of the normal is the difference in y, 3 minus a negative 1. 3 minus a negative 1 becomes 3 plus 1 over 4 minus 1. 4 minus 1. The difference in y over the difference in x. Very important. It's rise over run. Difference in y over the difference in x. This becomes 4 over 3. Therefore, the gradient of a tangent is minus 1 over the gradient of a normal. This calculation is done by flipping this and changing the sign. Become negative 3 over 4. That's a quick way to do that calculation here. Keep it simple. Flip this and change the sign. So that's the gradient of a tangent. So the equation of a tangent now, using this gradient and the point of tangency. So it's y minus the y value at the point is 3. Gradient of a tangent is negative 3 over 4 into x minus the x value at the point is 4. This time, because when I multiply through here, 4 will cancel this 4 and give me a whole number. I'm just going to expand the negative 3 over 4 across here. So I'm going to get y minus 3 equals negative 3 over 4x minus give me a plus. The 4 is cancel, I get plus 3. This negative 3 comes and add to that 3 to give me 6. So my final answer is, let me make this a little smaller. Right, so my final answer is y equals minus 3 over 4x plus 6. This is my answer right here. That's my tangent line equation. Question done. About 4 questions or 3 questions, and they're all the same. Specimen 2022, 2021, and 2019. 4 questions, and they're all basically the same thing. You have no business getting these questions wrong in exam. They don't make any sense. They're too easy, and it's the same thing they're asking all the time. Different values. Let's see. I'm desperate to see one that they ask something different. All right, it's a coordinate geometry as well. We can do it. All right, this one, coordinate geometry. Determine the pair of parallel lines. Determine whether a pair of parallel lines are parallel. Then parallel them have the same grade. Let's do this first. Determine the equation of the circle, the center, and pass through the origin. Easy. Pass through the origin, so it passes through the point 0, 0. Right? So the radius is still the distance from this to this. All it is, you have a circle like this, and it passes through the origin. So that the center is here, and this is a point on the origin. So like the tangent, like so. It don't have to be not a tangent. The axis go like this. Right? And this is a center point. I don't draw it correct to the point, but you get the picture. All right? Something like that. So the distance from the center to the origin is still the radius, right? So that it is. So this is a point on the circumference. It passes through the origin. So the radius is the distance between these 2 points, which then becomes easy because it becomes the square root of this square plus this square. I'm not subtracting anything. So the radius, zoom it up, the radius of the circle becomes the square root of 5 squared plus 2 squared. This is 25 and 4, that's 29. So it becomes the square root of 29. That's the radius. And then these are your center point values. This is your A and that is your B. So the equation, and they didn't tell us a form to give it in this time. They said determine the equation, so we can leave it in the standard form this time. So it's x minus the x value at the center point, which is a 5 squared, plus y minus the y at the center point is negative 2, so it becomes a positive 2 squared equals the radius squared. If we square this, it becomes 29. If you want to put by the square root of 29 and put the square on it, it's going to become 29 in any case. Right? It's going to become 29. So it will be x minus 5 squared plus y plus 2 squared equals 29. They did not tell me what format to leave it in, so I can leave it like that. Still correct. They did not tell me what format to leave it in, so I can leave it like that. All right. This one says determine whether these 2 lines are parallel. They are parallel, the gradient is the same. This line in the standard form y equals mx plus c, I make y the subject. I'm gonna get for this line y equals minus x plus 4. So going to have this first line is negative 1. That's the number in front of the x is negative 1. But this second line, if I make y the subject, right, I can transpose the 2y, multiple ways to do it. So I'm going to transpose the 3x and then divide by the negative 2. So first I'm going to get negative 2y equals negative 3x minus 3. I'm going to divide 2 by negative 2. I'm going to get y equals, when I divide this by negative 2, I'm going to get 3 over 2 x, and then this also is going to become 3 over 2. So we have line 2 is 3 over 2. All I'm going to say is that M1 is not equal to M2. Therefore, not parallel. They are not parallel because they don't have the same gradient. They are not even perpendicular. Because if they were perpendicular, then the product of the 2 gradients would be equal to negative 1. So they are not parallel. Want to go with that?
Yes, sir.
Yes, sir.
All right. That finishes that question. So this one didn't ask us for any tangent. All right. Let's go to 2017. 2017. That question was almost like a CSEC question a while ago. 2017. All right, let's see. These have any sugar on them. Hopefully we can find some with a little bit of sugar. All right, because these are really straightforward. This one says, they give us this equation, and I want us to express it in this format. So basically, I want to compute the square of these 2 values, to generate these perfect squares, and then transpose over to get the r squared. All right, so already know. So I'm computing the square of these 2 x values. So it's gonna become x, and then half of the 4 is 2 squared, and then minus the square of this, which is 4. Then I'm gonna compute the square of the 2 x values, which is this and this one. So it's gonna become y, half of the negative 2 is negative 1 squared, and I'm gonna subtract the 1 squared, which is 1. And then this minus 20 remains there. It's minus 20 equals 0. I'm working towards this. All right, so now I'm gonna get x plus 2 squared and y minus 1 squared. Then this and this and this is negative 25. Negative 25 will go on the right side of 25. 25 is the same as 5 squared. And so now it is in this format. Gotta go to that.
Yes,
Yes,
sir.
sir.
All right. It says state the center and the radius. So the center point, remember, we need x minus a. Remember now, we need it in the form x minus a squared plus y minus b squared equals the radius squared. So in this case, the minus a is positive 2. Right? So the center point is negative 2, and then the b is 1. So the a is going to be negative 2 because the minus a is positive 2. So the a is going to be negative 2, and then the b is 1. So the b is 1, that's the center point, and then the radius is 5 because this is r squared. So the radius r is equal to 5. Radius r is equal to 5 units. Radius is 5. All right, anything else? Let's see what else. It said determine the point of intersection of C and this line. So C is a circle. C is a circle, right? C is a circle. And they want us to find intersection of a circle. This line. So this guy's solving them simultaneously. All right. So we can use this format if we want, or we can use this format if we want. I'm going to use this. I'm going to use the expanded format. Let's write it out. X squared plus y squared plus 4x minus 2y minus 20 equals 0. Copy this down and paste it down here. So now I'm basically solving simultaneously this line and this circle equation. Let me write this better. This is 20. I'm solving simultaneously the line and the circle. And so you're supposed to get 2 points. You can just imagine you have a circle, you have a line, should cross at 2 points. All right. So to do this solution quickly, I can substitute for the y inside here and also inside there. Straight substitution for the y. All right. Straight substitution for the y. So when I do that substitution, I'm gonna get, let's see what I'm doing. Let's call this line L and call this circle C. Line L and circle C. Line L and circle C. I'm gonna sub L into C. Line into the circle. I'm subbing for y. So I'm gonna get x squared plus, where this y is, I'm gonna put 4 minus x squared plus 4x, where this minus 2 times, where this y is, again I'm gonna put 4 minus x minus 20 equals 0. That's a quadratic, you know. I just need to expand it out to the standard form and solve it as a quadratic. Expand this first. I'm going to get x squared plus first term squared is 16. Twice the product of the 2 is minus 8x. Second term squared is plus x squared plus this 4x. Expand this with the negative 2. I get negative 8 plus 2x. This and this is negative 8. This time this is plus 2x. And I'm subtracting 20 equals 0. So this x squared and this x squared, 2 of them. So 2x squared. And then this x and this x, that's 6x. So I get plus 6x. No, this x as well. So what are my x's? This, and this. That's negative 2x. Negative 2x. This is 6 of them minus 8. So negative 2x. So my x is become negative 2x. And the values now. This is 16 minus 8. That's 8. 8 minus 20 is negative 12. That's negative 12 equals 0. But you agree with that?
Yes, sir.
This can be divided through by 2. See, I don't have a lot of space to solve it. All right, that's the problem with these questions. Sometimes they don't give you a lot of space. make this smaller. Don't give it a lot of space. You have to be very efficient with your work. All right, so be very efficient with your work. So this becomes x squared minus x minus 6 equals 0. That factorizes into x and 2 and 3 as factors of the 6, and that definitely greater put the minus sign, so put the minus here and the plus here. And so it is x equals 2, x equals minus 2, sorry. X equals negative 2 from this factor, and x equals 3 from this factor. Then to find the y value, I can just write them down from this one. From this one, the y is going to be, I'm going to substitute negative 2 in the line equation right here. So it's 4 minus a negative 2. That's 4 plus 2, which is 6. I'm going to get y equals 6. And for this one, I'm going to plug the 3 right here for the x. 4 minus 3 is 1. So I'm going to get y equals 1. And so my solution, let's put it in a box right here. Solution would be negative 2, 6 at one point, negative 2, 6, and 3, 1 is another point. 3, 1 is another point. And these are my answers in this box. Are you okay with that?
Yes, sir.
Good. I'm gonna shift this down. All right. So that finishes that one. Let's go and do 2016. 2016. 2016 is right here. Right. So this one, I think we're gonna have to get the page right on. So this is back to the normal kind of question now again. All right, let's see if we can work it here. 2016. It says M and N are endpoints of a diameter of a circle C. Determine the equation of a circle. So these are endpoints of a diameter. It means that the midpoint between these two are the center points. And then the distance from the center point to any one of them will become the radius. But I can agree with that. But I can agree with that. So I'm going to center O. So I'm going to write the center is this. Center point equals the midpoint between these 2 points. So the average of the x values, average of them, which is 3 minus 1 over 2. And the average of the y values, that's 2 and 4. 2 plus 4. 2 plus 4 over 2. That's the center point. The center point is the average point. The midpoint is the average point. The midpoint happens to be the center. This works down to, this is 2 over 2, which is 1. This is 6 over 2, which is 3. So the center point is 1, 3. The distance between the center point and any one of these 2 points become my radius. All right? So I'm going to calculate the radius right here. The radius R equals the square root. I'm going to do the distance between this one. Let's use these two. Underline the ones that I'm using. I'm going to use one with two positive, with the positives. I'm going to use this one, and I'm going to use the center point right here. All right, I'm going to use those two. Let me underline this one as well. So first is the difference in the x value squared. So it is 1 minus 3 squared. 1 minus 3 squared and 3 minus 2 squared plus 3 minus 2 squared equals, now this is 1 squared, no, not 1 squared, this becomes 2 squared plus 1 squared. That becomes 5. 4 and 1 is 5. This is negative 1, negative 2 squared, same as 2 squared. So this is 5, root 5. So the radius is root 5. The radius is root 5. And so the equation of that circle is x minus the x value at the center point, which is 1 squared, plus y minus the y value at the center point, which is 3 squared, equals this radius squared, root 5 squared, which becomes a 5. And so we can write as x minus 1 squared plus y minus 3 squared equals 5. Root 5 squared is 5. I think I could have left this. They give them more options to see. It doesn't matter, but that is it. That's the equation. But good?
Yes, sir.
All right. Then we want to find the equation of a tangent at this point. Same thing again. Let's sketch it over here this time. In this space. Let's sketch it over here. So I'm gonna draw my circle. Put in my center point, which is that 1, 3. And my point is -1, 6. It's not to scale. This diagram is just a schematic, so don't care where the points are. It's a schematic, and I'm going to do it the same way every time. So I'm going to just draw a tangent there. Put a point there. My normal line is this. My best friend. Normal is my best friend. As it helps me to find the tangent, they are perpendicular. And the point we're working with is -1, 6. -1, 6, the point I'm working with. So first, as usual, I'm going to find the gradient of the normal first, because I have the coordinates of 2 points it passes through. So the gradient of the normal is a difference in the y values, which would be 3 minus 6. Let's do subtracting them that way. This point minus this point that way. 3 minus 6. 3 minus 6 over 1 minus a -1. 1 minus a -1, 1 becomes 1 plus 1. It's become -3 over 2. That's -3 over 2. That's going to have the normal. So the gradient of a tangent, therefore, is -1 over the gradient of a normal. To do that, we flip this and change the sign. It becomes simply 2/3. 2/3 becomes the gradient of your tangent. When you use this tangent gradient and this point, we have to get the equation of a tangent. So the tangent becomes y minus the y value at the point is 6. Gradient of a tangent is 2/3 into x minus the x value at the point is -1. So it actually becomes a +1. I'm going to multiply the 3 across here, and I'm going to get 2y minus 12 equals, I'm going to multiply the 2 inside here. So I'm going to get 2x plus 2. Transpose this 12 and add it. I'm going to get 2y equals 2x plus 14. This can be divided by 2, you know. Usually I don't get that. Made a mistake? Yeah, I made a mistake. This is 3 I'm multiplying by 3, not 2. So this line is wrong. It's supposed to be 3 times these. That's 3y minus 18. 3y minus 18. So this is actually 3y. Right. So this becomes 3y equals 2x plus 20. That is it. That is it, guys. All right. Anything else? Nope. That's it. Let's go to 2015. 2015 next. 2015. Remember, guys, after a break, coming back after 3 hours, we'll do another session. More maths equals better maths. More maths equals better maths. Every time. All right, let's go. Tell mom to take care of the dog, please. Still in the class. All right, guys. So this gives us this equation again. We have a circle. We want to determine the center and the radius and the equation of the normal. Straightforward. All right. So we're gonna put it in the standard form first. All right. So we have x squared plus y squared minus 12x minus 22y. Shift this over. Plus 152 equals 0. I'm going to compute the square of these two terms first. I'm going to get x half of the negative 12 is negative 6 squared minus the square of this 6, which is 36. I'm going to compute the square of these two terms. It's going to become y half of the 22 is 11, subtract 11. Don't forget the square. I'm going to subtract the square of the 11, which is 121. Running out of space. I'm going to add back this 152. Let's put it here. So plus 152 equals 0. All right. I'm going to get x minus 6 squared plus y minus 11 squared. Write the numbers now. Somebody can write this for me. That and that and that. Write those three. So it's negative this and negative
minus
that.
5.
Minus 5. So minus 5 goes over on the next side and becomes a positive 5. All right. And I'm going to square root it and then square it. So I can see that my radius is root 5. So that center point, center for part A is 611. Because that's A and that's B, 611. Radius for part 2. The radius of part 2 is root 5. Radius for part 2 R equals the square root of 5 units. That's the radius. And then the one the equation of the normal. Actually, want the normal, guys. Right? They want the normal at this point. So they want the normal in part 3. We don't even have to sketch it. Because the normal will pass through those 2 points. The normal will pass through the center point 611 and also pass through 410. We just need the equation of the line to do those 2 points. So the grade of the normal, because that's the center point and that's the point of tangency. Grade of the normal, difference in y by difference in x. So is 11 minus 10, that's the difference in y, over 6 minus 4, that's the difference in x. Difference in y by difference in x, that becomes 1 over 2. Using that normal, and we're using the normal gradient with any one of those 2 points. So the equation of a normal now, the equation of that normal, let's say we're using, let me underline a point that I'm going to use. Let's say I'm using this point and the gradient. So the equation becomes, of the normal, is y minus the y over the point, which is 10, equals gradient of the normal into x minus x over the point, which is 4. Multiply the 2 across here, I get 2y minus 20 equals the 1 inside here is simply x minus 4. So 2y is equal to x. You know what is positive 20? I get 20 minus 4 is 16 plus 16. Let's just test it with the other point, this point, and see what happens. Or it will be y minus the y value at this point is 11. 11. The gradient is still a half into x minus x value at the point. Here is 6. Multiply the 2 across here again. I will get 2y minus 22 equals 1 times here will be x minus 6. So 2y will be equal to x. Bring over this 22 becomes 22 minus 6, which is still 16. So the same equation which we're going to use. So that is a normal equation. Are all right with that? 2014, 2013.
Yes, sir.
Yes, sir.
3 to go. 3 to go. I'll finish with this topic. 15 minutes. Yes. 3 to go and 15 minutes. Finish with this topic. Remember, starting back in 3 hours, guys. We're gonna do logs, indices, surds, logs, indices, surds, inequality, and linear reduction. And do some linear reduction as well. We're gonna do all those questions. Finish off module 1. And then tomorrow now, we jump onto module 2. Module 3, I mean. And this is module 2 that we're on. All right, so let's finish off module 1 this evening. All right. All right, let's go. 2014. Maybe we only need about 2 hours this evening. 3 hours from now. All right, 3 hours from now. 2014. One maths equals better maths. 2014. To study hard in order to pass exams easily, guys. You have to study hard. Okay. Can't go normal. Don't get excellent results by going normal. You have to go hard because you want to get good grades. All right. So this says determine the value of k such that this line and this line are perpendicular. So it's quite simple. The perpendicular, the product of their gradients is -1. When 2 lines are perpendicular, the product of their gradients is -1. So the first line is x. First line is x plus 3y equals 6. We need to extract the gradient from that. So we need to make the y alone the subject. Transpose the x and divide by 3, and we get y equals -1/3 x plus 2. What can I do with that? In the first line?
Yes, sir.
Yes, sir.
So for this line, the gradient is -1/3. The second line, I'm going to get a gradient from it as well. So I'm going to write it out. It is kx plus 2y equals 12. I make y the subject. I'm going to get y equals minus k over 2x plus 6. But I get that for the second line.
Yes, sir.
Yes, sir.
So therefore, this is the gradient of that line. So for this line, the gradient, let me shift it over. Shift it over. Right, so for line 2, the gradient of line 2 is minus k over 2. With them perpendicular lines, they are perpendicular. So the gradient of line 1 times the gradient of line 2 equals -1. That's what you're setting up and solving. So it's -1/3 times minus k over 2. That's equal to -1. This minus and this minus cancel each other. So this side becomes k over 6 equals -1. Agreed? Because the negatives cancel. Multiply the 6 across here. And so the k is -6. K is -6. And that's my answer right here. But good? Perpendicular line, the product of the gradients equal -1. Product of the gradients is -1. Parallel lines, the gradients equal. Gradients equal. Done. This part you know says, this part you know, that's the equation of a circle part now. What does it say? It says, a circle of radius 5 has a center point at the intersection of the 2 lines above. Determine the equation of it. So they gave me the radius. Look at it now. They gave me the radius. So this is my r. R equals 5. And the center point is at the intersection of these 2 lines. So I need to find where the 2 lines intersect. So now that I know by k is -6, I'm going to write by the 2 equations and solve them simultaneously to find the center point. Good? So the first line is x plus 3y equals 6. The second line, because I know the k is equal to -6, then this becomes negative 6x. Negative 6x plus 2y equals 12. So I'm solving those two equations simultaneously. What I can do to eliminate the x to start, I can multiply this first equation by 6. So let me shift this down. I'm going to multiply the first equation by 6. Right? So I'm going to multiply this first equation by 6. I'm going to times 6 on this first equation. And it's going to become 6x plus 18y equals 36. And then I can add these two equations and eliminate the x. So I'm going to add them. I'm going to add those two equations. When I add them, these are eliminated. This becomes 20y equals, this becomes how much? That becomes 48. So y equals, divide by 2 first, we get 24, and then we get 2.4. Agreed? But agree with that? For the y?
Yes, sir.
And then we get 2.4 for the y. I'm going to take this 2.4, I'm going to substitute it back for the x up, for the y up there. So I'm going to get, and I'm going to get x plus 3 times 2.4 equals 6. And write this out for me now. The x is equal to 6 minus this, minus 3 times 2.4. What is that? X equals what? I'm going to test this. Minus how much?
1.2.
Minus 1.2. I want to test them in this equation to see if it works, if it's correct. Let's test them. So it's negative 6 times negative 1.2 plus 2 times 2.4. Calculate this for me and tell me if it equals 12. Calculate it for me. Equal to 12, then we know say correct. Quiet no dog. She's This work out to 12, anybody?
Yes, sir.
So it equal 12. So that means that the points are correct.
Yes, sir.
I just want to do that like a check, because usually we don't get decimals with these questions, right? So it means that the center point on this question, center point is negative 1.2, 2.4. Remember the radius r is just 5. So the equation is x minus a squared plus y minus b squared equals r squared. So dropping these values now, right? So it's x minus and negative 1.2 becomes x plus 1.2 squared plus y minus 2.4 squared equals 5 squared. And now can leave that as my answer. They did not tell me what format to put it in. That's the equation of a circle right there. But all right. What good at that?
Yes, sir.
All right. 2013 and then 2012. 2013 now. Let's see if there's anything different about them. So you notice these earlier questions are a little bit different from the more recent ones. So if you're going to look over anything, I don't want to look over too much. You can look over the more recent 5 or 6 past papers, right? You have to go all the way down to 2012 and 2013. Structure has changed significantly since then. We're just working them because we're just practicing. So we're at what? 20, which one we just do a while ago? We just did 2014, so we need 2013 now. 2013, which is this one. 2013. All right, it's right here, right on it. So I'm talking about this question right here, so now, right? Let's see what we're supposed to do. It says a circle has this as a center, right? And passes through this point. Express the equation of a circle in this form, where HG and K are integer to be determined. So in other words, we must find the equation of the circle in this form. That's all. So it's a similar question. This is a center point and the path is through that. So it means that AB is a radius. That those 2 points give it the radius, right? So we can set up over here. So the radius is AB. So the radius equals the line AB, length of the line AB, which is equal to the square root between these 2 points. The difference in the x value is squared, which is 10 minus 2 squared. 10 minus 2 squared plus the difference in the y value is squared. 7 minus 1. 7 minus 1 squared. That becomes the square root of 8 squared plus 6 squared. I can tell you that this is 10. It's a 6, 8, 10 triangle, Pythagorean triple. Work it out, we're going to get 10. That is 64 plus 36 becomes 100. The square root of 100 is 10. Well, that is 10. So the radius is 10. The radius is 10, and this is a center point. So the center point AB, but this is the R now. Center point AB is equal to 2, 1. So the circle equation is x minus a, which is 2. Don't forget the square, plus y minus b, which is 1, is equal to the radius squared, 10 squared. We want it out in the general form. This is the standard form. They want the general form. So I have to expand this out. Expand this first, we get x squared minus 4x plus 4. Expand this out, we get y squared minus 2y plus 1. Bring over the 100, we get minus 100 equals 0. Consolidate. X squared plus y squared. That's this and this. This is all the x value there. That's minus 4x. That's all the y value there. It's minus 2y. Then the values know. 5, 4, and 1 is 5. 5 minus 100 is negative 95 equals 0. That is the answer. That is the equation of a circle. Basic stuff. Next part says, the line L is a tangent to the circle at the point B. This is the point B. Find the equation of line L. So in other words, you must find the equation of a tangent at this point. Same thing again. Same thing again. Right? Same thing again. Nothing different. We're going to sketch it again. Center point is 2, 1. B is a point. We're going to find this tangent line. T for tangent. The normal is the best friend because it passes through those 2 points there. That point, they tell us, is the point B, which is 10, 7. This is our normal, our best friend. Normal is our best friend. It helps us to find a tangent when we're doing circles. When we're doing equations of curves, then the tangent is our best friend. Tangents help us to find the normal when we're doing equations in coordinate geometry, like dy by dx and so on. We're going to see that when we do differentiation tomorrow. All right, so ready now. Same thing again. We're going to find the normal first, our best friend. So the gradient of the normal is the difference in y by difference in x. 7 minus 1. 7 minus 1 over 10 minus 2. 10 minus 2. Weight of the normal becomes 6 over 8, which is 3 over 4. The tangent is perpendicular to it, so the gradient of the tangent is minus 1 over the gradient of the normal. This calculation is done by flipping this gradient and changing the sign quickly. Negative 4 over 3. Using this gradient and this point to get the equation of the tangent. So the tangent becomes y minus the y value at the point is 7. The grade of a tangent is -4/3 into x minus the x value at the point is 10. I'm going to multiply this 3 across here by these two values. And I'm going to multiply this -4 inside the bracket by those two values and eliminate those fractions. So I'm going to get 3 times these, which is 3y minus 21 equals -4 times these is -4x plus 40. So I do have in the fractions working. So it's 3y equals -4x. This 21 comes over and add to the 40, gives me 61, positive 61. That is my answer. That's the tangent. Done. Very good at that. Very okay?
Yes, sir.
Yes, sir.
All right, so just on the time to end the class. So we just have one more question to do. And we shall end for 3 hours. And you come back and we're going to finish off module 1. All right, finish off module 1. All right, so looking for the 2012 paper now, 2012, which is right here. We're doing all of them. Leave no stones unturned. Do all of them. Don't know what's coming on the exam paper. A repeat question must never get you. A repeat question must never get you on the exam paper. Do all of the past papers, every single one of them. A repeat question must never ever get you. If something's gonna get you in the exam, let it be something else. Oh, that's 2022. 2012. This one. Never let a repeat question get you in an exam paper. You set it already and you set it again, you must crush it. Always crush repeat questions. All right? That's why I must do all the past papers, leave no stones unturned. This question says, the equation of a circle is this. It says this line is that. Show that the line passes through the center. So if this line passes through the center, then the center point satisfies the equation of that line. Right? That's all we need to do. So we need to find the center point from this. Right now, I can know, center point is 2, -3, because it's minus half of this, half of that. Right? Minus half of that and minus half of that. But that's the center point. But let's go for the traditional way to do it, which is compute the square. So it's x squared plus y squared minus 4x plus 6y equals 87. Complete the square of these two terms. I'm going to get x. Half of this is -2 squared minus the square of this, which is 4. I'm going to complete the square of these two terms. And so it's going to become y half of this is 3 squared minus the square of this 9. The square of that 3 is 9, and that is all equal to 87. X minus 2 squared plus y plus 3 squared. This and this is 13. 13 goes over on this side and add to the 87 to give me 100. 100 is the same as 10 squared. So the center point is 2, -3. 2, -3 is the center point because it's a plus 3. We want it can be written as y minus a -3. So that's why that is the -3. All right. So, and the radius r is equal to 10. So if this line passes through the center of the circle, x plus y plus 1 equals 0. Passes through the center point. 2, -3. Then 2, -3 can be fitted into it and satisfied. 2, -3 satisfies the equation. So can I run a little test to see if it is true by seeing if the points satisfy the equation. So plug in the 2 plus the y, it's -3 plus 1, and this works out to be 0 indeed. So therefore this is true because the points satisfy the equation. So we have shown, so therefore shown. Right? Show that this line passes through the center of a circle. So that is it. By showing that it satisfies the equation of a circle, it means that we have shown that it is indeed passes through the center because the point satisfies the equation of the line. Right? So it passes through the center. This is find the equation of a tangent. All right? Find the equation of a tangent. So this was a little sugar question that I tried to put on it. You want the tangent equation through this point. So it's more of the same, really. All right, so more of the same. So sketch it again. If I do it 100 times, I will sketch it 100 times. All right, do the same way when it's the same question. Center point we said is 2, -3, 2, -3, and we want that -6,3, -6,3 right here. And we want a tangent through that point. Bam. That's a tangent line. The normal, as always, is a best friend because we're working on a circle. So the normal is our best friend this time. When we're working on an equation and a curve, tangent is our best friend. So this is your normal line. And the point of tangency is -6,3 right there. -6,3. Same thing again. They are perpendicular. The gradient of the normal first, you can find the difference in y by difference in x. So there's 3 minus a -3. I can go the other way and say -3 minus 3. That's -3 minus 3. That's the difference in y. 2 minus a -6. 2 minus -6. So the gradient of the normal becomes -6 over, this becomes a positive over 8, which then means that this is, right beside it, is -3 over 4 when we simplify it down. Therefore, let's go for the tangent now. Gradient of a tangent is -1 over the gradient of the normal. This calculation is done how? Flip this gradient and change the sign. It becomes 4 over 3. Flip it and change the sign from negative to positive. 2 perpendicular lines cannot have the same sign of gradient. One negative, the other one must be positive. So we're using this gradient with this tangent point of tangency. So the tangent equation becomes y minus the y value at the point of tangency, which is 3. The gradient is 4 over 3 into x minus the x value at the point of tangency is -6 minus becomes a +6. I'm going to multiply the 3 across this side over here. I'm going to multiply this 4 inside here. So we eliminate the fractions. All right. So the 3 multiplied over here gives me 3y minus 9 equals the 4 inside here gives me 4x plus 24. So 3y equals 4x. This 9 comes over and add to the 24 to give me 33 plus 33. And that is my answer right there. Bam. Very good.
Yes, sir.
Yes, sir.
And that is that for now. So will you join me again in 3 hours time?
Yes, sir.
Yes, sir.
Surge. We're gonna do surge, logs, indices, inequality, linear reduction. Those questions are like really very easy and short and quick and fast to do. So you should be able to finish all of them within 2 hours. If you stretch to 3 hours, well, fine. Right? We have to put in the work now. Exam is on Monday. Put in the work now because we want the results. Well, exam is on Tuesday. And the last class is on Tuesday. So I want to revise everything and leave no stones unturned. Don't know what's coming on the exam, so preparing for everything that's possible. All right, so let's cover those topics later now. I want to do all the questions CSEC ever set since I started doing admins. All the questions from 2012, 2022, and the specimen. So let us aim to do that, cover all the questions. All right, so see you in 3 hours time, everybody. I'll send the link again. All right, so see you in 3 hours time. Bye. Get some rest.
Bye, sir.
Bye,
Okay.
sir.
Bye-bye.